This conference will now be recorded.
Good morning, everyone. We're a little shy on attendance this morning. I may drag my feet on the first topic, but I will get right into it so that we have every chance of covering all the stuff we've got on the agenda today. As always, you've been really great about muting and unmuting. This is our interactivist day, so don't don't forget to unmute when it's time. In the meantime, if it's muted, the recording comes out a little bit cleaner. Also, a reminder about the phone number so that you can call in if you don't make it with your speakers and your headphones or your microphone. We've been on this journey of model it, document it, calc it, list it, and coordinate it. Um, and today we have left over some collaboration discussion, some hanger discussion, and some listing. So I'm going to get right into that stuff, and then we will have been through this sort of checklist of everything involved in a project. But then I have some other topics that we we whizzed by during class over the last couple of weeks, and I want to revisit them and get into a little bit more detail on pumps, standpipes, and sloped pipes in a dry system. So we are here. We've all got sheets from the projects that we've been working on, and the sheets have got floor plans, ceiling plans, section lines, site plan, uh, details of several sorts. Um, we do need today um, to get the calculations, the hangers, and the first topic we're gonna dig into is collaboration. So last week we spent, last week we spent time on coordination, and I'm having trouble getting that to go on. And coordination is the process of making sure the blue stuff doesn't hit the red stuff. Everybody's got to get out of each other's way. Collaboration is whether you're in each other's way or not, you all want to be working on the same project at the same time. This, probably more than anything else, is the driving force, I think, um, that that requires that we move either to Revit or something like Revit that allows for that simultaneous um, operation, that simultaneous work be done by the plumber, the electrician, the sheet metal guy, the fire protection guy, and the architect. In order to make that happen, um, you can't all gather in one building and work off the local drive or the shared drive in that one building. That actually needs to be done in the cloud. The picture I've got on the screen here talks about the the syncing to a central model, um, and I want to walk you through this or talk you through it. I haven't gotten any panic phone calls from anybody that has actually dealt with this operation. I think the the project manager, the the infrastructure built around this process is pretty well managed by the architect, the engineer, the general contractor, the people trying to pull that all together. But I thought it was really, really important that I sort of expose to you or cover with you what that's about. Um, the concept is that we could have, I'm showing just a yellow computer and a green computer. Those two are going to work on this project at the same time. And in reality, they are working on a local copy, something on their hard drive at the speed that you've been accustomed to working with Revit. The work gets done there on your local computer. Um, in the past, we've been used to, oh, well, send me your new file and I'll put the new file in place. And when I'm done, I'll give you my file and you put my file in place. That that involves sending around, often by email, very often by posting to BIM 360 Docs or to something like Procore, or a cloud service. It could be OneDrive. You're posting an entire file. Um, this collaboration process substitutes synchronization for copying files. So you've got the yellow computer in this case has a local copy. When you draw 4 branch lines, it memorizes that the last thing you did was draw those 4 branch lines. And periodically, like every 15 or 20 minutes, you get reminded to synchronize. You don't copy your entire yellow um, copy of the whole sprinkler system or your whole model. That doesn't get copied. Just those 4 branch lines get synchronized to the central model. At the same time, and I'm showing in the green computer is working on the ground floor and the yellow computer is working on the second floor. The 4 branch lines drawn, or the 5 branch lines, let's say, drawn on the ground floor on the green computer, those get synchronized, added to the central model. And it's a two-way process. When the green posts or synchronizes their 5 branch lines for the ground floor, at the same time it collects the 4 branch lines from the second floor. And similarly, the second floor posts their 4 branch lines to the central model and collects the 5 branch lines that were added on the green computer. This process is used in Teams. It's used in Word or Office 360, um, where you can actually see someone else typing in a Word document and you can make comments on the Word document at the same time. And the concept is the same, is that there's a central copy of that file. You're working on a local copy and your changes are getting synchronized to that central copy. Um, you're likely to get called into this process from uh, a big contract, maybe a 20-story high rise or something, and they will tell you at the outset this is going to be a collaborated project. More and more sprinkler contractors are getting drawn into design build projects or getting drawn in by the um, mechanical engineer to serve as the fire protection consultant during the process, during the build out of this building, even before there's a contract let for the sprinkler system. That being the case, the project is changing literally daily, and uh, there's time for this synchronization. There's not time to be sending files around and converting them from AutoCAD to Revit and back and forth and all of that stuff. There's just not time for that. So this process serves those quote unquote fast paced large projects. Um, when you're when you're signed up for one of those, you will need to have a BIM collaborate, and I apologize for losing track of the name. Autodesk changes the name of their products almost annually. It was called Revit coordination, Revit cloud coordination. Um, if it's a if it's an AutoCAD BIM 360 project where you're going to be doing collaboration, you'll probably need to get a subscription for that. Sometimes it's been provided by the general contractor. Sometimes he just says, if you want to work on this job, you have to have that subscription. I'll warn you ahead of time. That's about $1,000 a year per seat. So if you want to warn your salespeople about that's a cost that may be built into their estimate, they may want to make sure they build that in. Um, Without that, you can still exercise this process just on a little bit more local basis. The central model needs to be hosted someplace, needs to be saved to a disk drive that the yellow and the green computer can work to. If that's Autodesk's 360 BIM, Autodesk Construction Cloud or BIM 360 Docs, those are two different flavors of cloud storage by Autodesk. If it's that, that's when you need that $1,000 a year license. If it's your G drive or your X drive or your engineering drive, the same process works, but you're supplying the location and the storage, and this process works with the tools you already have on your computer. So the process is the same. Where that central model is stored is what's different. Questions? I've got like 5 more slides to step through this process, and I'm not going to actually do it, but step you through it. But at this level, does anyone have any questions on what this is about and why it even exists? Okay, and I'm going to add one more thing then to why it even exists. Um, and I think the short answer is um, as built drawings. This white central model should be owned by the building owner, and it should be owned at the very inception of the project. And as the architect conceives the size and shape of the building owner can see that in that cloud model. Um, while it's being constructed and coordinated, he should be able to see that. When it's complete, he will continue to see that, and he'll use it for maintaining the building. When he wants to know what kind of light fixture is over Sally's desk on the 15th floor, he can simply open that central. He can be one of the yellow or green computers and open that central model and go get to the 15th floor and look at the mini me version of the light over Sally's desk and know whether he's got stock to replace it or if he needs to order one before he schleps his ladder up there to do that. Um, the BIM 360 or Autodesk Construction Cloud envisions other users of that central model that don't have Revit, but they have Autodesk Construction Viewer that lets them, like Navisworks, open and interrogate that model without actually authoring or changing it. Um, so that makes that central model useful to way more than just the people working on it. Okay, so this first slide is actually not part of working on a collaborate model. It's a reminder of what we did on the first day and what we did on the end of the first day or the beginning of the second day. It's the checklist if you're starting a new project. And I'm going to read it through. You want to verify and prepare the files to be inserted. So before you link a Revit background, before you um, link a CAD background, you want to open that background, look at it, and know what to expect when you link it into your project. Once you're, and while you're doing that, you're going to pay attention to what did they use for a reference level so that you can work at that same starting Z coordinate, uh, the height of level 1. So then you're going to put those away. You're going to start a brand new project using a template. It's got nothing in it. You're going to copy the toolbox to make sure it's got the latest and greatest Hydrotech content in it. The template typically comes with 2 grid lines and a section line, just so you've got some reference. And then you're going to make sure that level 1 matches the level 1 or the reference level of everybody else's work. Then you're going to insert and align the backgrounds. And typically you're going to align your grid lines to theirs so that you're working in the same place as everybody else. Then you're going to create some working views, and now you're off to the races. So that's exactly the same, whether it's a standalone work on your computer, do what we've done in the last week or two, or whether it's what needs to happen in order to create or work on this central model. Once you've done that stuff, you're going to switch gears and take that project and turn it into a central model. And to do that in Revit, on the collaboration ribbon under Manage Collaboration, there's a button that says work sets. And when you click it, you're going to get a warning that says, oop, oop, this is going to turn into a central model. Well, that's why you're doing it. So you're going to say yes. And that button is going to give you a dialog box that you can set up work sets. According to that picture I had before with the yellow machine and the green machine, you're going to create a work set called Allen second floor piping, and another work set called James ground floor piping, and another work set called Josh uh, upper lobby area piping, and that that allows the work that I do on the second floor to get labeled as my work, and it basically lets me protect that work and keeps Josh from changing it without him knowing that he's sort of stepping on my pipes. So once you've created those logical work sets, each user, you resave that then, and you save it to the G drive or to the engineering drive, that drive that's available to everybody. In the case of a cloud model, you're going to save it to Autodesk Construction Cloud. Then, after the work sets have been created and you saved it, you close it, and that's the last you're actually going to work on that physical file. Each user then goes to open that file and it says, oh, that's a central model. Do you want to create a local copy on your machine? You'll say yes, and that'll, for the first time and probably the only time, it's going to copy all the stuff from that central model, from that central storage drive down to your local drive. And then the next really important thing is to make sure that you activate your work set and you keep working on that work set. As you add pipes, they'll get tagged with your work set name, and periodically, like every 15 or 20 minutes, you'll get reminded that you should synchronize. Those are the two most important things to keep in mind if you're working on a central model. Make sure you're on your work set and sync often. Most of what I've gone over steps wise already is going to have been done for you on the engineering and architectural side. But you're going to want to create, and they may very well invite you or require you to open the mechanical plan. And when you open the mechanical plan, you'll have a work set for fire protection, and you're going to make sure you're activating the fire protection and work on that mechanical plan. If you're doing this in your own office, then you may want to create your fire protection model as a central model and have it link those other models. But then locally, you're opening that fire protection plan and making sure, again, you activate your work set and you sync often. So there it is written out. That's that whole process. I'm not sure that there's great value in stepping through all the details of it, because it might be a week, it might be a month, it might be 2 years before you get sucked into one of these, and all the details will be mush by then. So I've tried to keep this part short and sweet so that you're aware of it, you've got an idea of the concept of it, and you will likely have an IT person from the general contractor's office guiding you through. He set all this stuff up, and he's going to set the rules for which work set and how to work on it. I'll come up for air again. Any questions on collaboration? Have any of you been sucked into one of these projects yet?
Yeah, Alan, me, my first job in Revit as well. So
Um, so I pity you, or I sympathize with you, but Was this at all helpful, Josh, to get maybe an overview of it?
Yeah, no, I was looking forward to actually getting a full understanding of how it works. I mean, this project that we're working on is a ginormous high school, so I think we've got like I can't even count you how many work sets we have, just because of all the different zones and levels and stuff. But basically, it locks you out of touching sprinklers
Other
or pipe
people's
or
stuff.
whatever other stuff who are
Yeah.
currently working on the same project. So it's pretty nifty.
Um, which is uh, definitely annoying at times and meant to be useful in the big picture. But if you've got this overview, hopefully that can help you make a little bit more sense of it. Um,
Yes, sir.
so for sure, Josh, I'll invite you if you do get stuck along the way and you'd like somebody's shoulder to cry on, let me know. Um, but but I haven't gotten a lot of questions related to this overall workflow because for the most part it's managed by in your case is it the general contractor?
Yeah, yeah, and it also helps that you know my coworker is my boss is also my dad who so I mean I can scream at him across the shoulder be like hey relinquish or hey what are you doing get out get off so that
Yes,
also
yes,
helps.
yeah, yeah, there is messaging, but if you
Yeah,
can do it by yelling it's that much easier.
yeah, makes it a lot simpler. So
Excellent, good deal. Well, thanks for sharing. So I'm moving on to talking about getting ready for stock listing. We were pretty much dressed up, and last Thursday we got to do the couplings part of this. I'll just remind you, we did couplings just by putting one in and adjusting the dimension to put it exactly 6 inches off the wall. We put couplings every 12 feet by clicking near one end of a straight run, and it found the bitter end, went 12 feet, 12 feet, 12 feet till it ran out of 12 feet. And then we did detail lines across a bunch of pipes and said put the couplings every place those detail lines cross the pipes. And there was another one I'm not sure I showed you. I'll remind you, and we have the equivalent here in hangers where we could say put a coupling 10 feet off the end and then go every 20 feet after that. Um, so so the couplings are on the project that we're going to open and start working with today. Um, let me talk about this some more, but while I'm doing that, let me get Revit opening because that always takes a minute. And while that's opening, I'm going to just point out we're going to use like 6 different kinds of hangers: ring hangers, trapeze hangers, pipe stands, riser clamps, lateral braces, longitudinal braces. So we got lots of different kinds of hangers, and each of the hangers can be put in at least 4 different ways. Just put one here, put one there, put one the other place. Or we can pick a big old window and just say, put hangers on all those pipes that I just clicked on. Um, or we can use that interval thing that says start here and go a foot and then go every 10 feet after that. And again, we can draw detail lines across the pipes and say every place that detail line crosses, then put a hanger. So that's like four different methods on six different kinds of hangers. There's lots and lots of ways to get hangers on there. Um, the hangers are best placed, not because of the program, but because of the physical reality of it, are best placed on the steel members or on the structure if you can. And I'll remind you about the view range having a big part to play in whether you see the steel or not. Um, the hangers that Hydrotech created were built on the idea that if the pipe moves, the hanger's going to move with it. To make that happen, we attached it to the cylinder, the circle, the disc at the end of the pipe. So you could think of a pipe as a disc and then a tube and then a disc. We're hosted on that disc at one end of the pipe or the other. That makes them not as easy to copy and just copy and paste them all around because they want to stay hosted to that particular pipe. So as a result, it's best to do the hangers near the end of the project, not near the beginning when you're recreating pipes and moving them around and adding new pipes and all of that stuff. So I have Revit open, and I'm going to go open the project that I sent you this morning. So in HES, HES, online training, intermediate training, I'm going to go to start of day lesson 5. So I'm opening that. And again, I purposely unloaded the links so that you wouldn't get stuck waiting on an upgrade from 2023 to the version that you're using. So I'm going to jump right in and go reload those links. So I'm going to go to Insert, and I'm going to go to Manage Links. And there's my small medical facility architect and engineer, and I'm going to take the architect, click on that name and say Reload From, and I'm going to reload it from CHES Revit Training, and under Revit Training, I'm going to go to Revit Project Files, and I'm picking on the 2023 version to reload that, and then I'm going to click on the engineering link and reload that from the engineering Revit 2023 for me. And that gets us almost exactly to where we left off last Thursday. So we're going to talk about finding the steel. I think I'm going to use the second floor as my starting place, and the second floor framing is almost all steel. So I'm going to find.
Alan?
Hey, go ahead.
Mine came up with a warning after I tried to load it. It says,
And what did it say?
outside of its room.
Easily ignore. It's a warning, and you can say, yeah, fine. That would be if you had, I guess it's a little curious because you and I thought we were doing exactly the same thing. If you want to check it, I'd suggest going to the ceiling plan under mechanical and just try the second floor there. That's a place where I've got the ceilings lined up to go on the plot, to go on the sheet, where it has room names and ceiling heights. And see if you're missing a room name, you'll have a hard time knowing, or if you're missing all the room names, that would be easier to find out.
So 6 second floor ceiling plans?
Yeah.
Yeah, I'm not showing any
Room names or
room names or room heights.
or ceiling heights.
Right.
That's I want to be specific. That's under mechanical in the project browser. It's under mechanical under FP plot, the ceiling plan second floor.
Got it.
But still no room names or ceiling tags.
No, I tried to click on it. It won't open. Oh, hold on. Yeah, nothing's showing up when I click on those. No picture.
Okay. Nothing, including not even room.
Not even a plan. There's just blank.
Okay. Then why don't we go back to, let me remind me who's having this trouble so
Chris.
I can get Chris. Let me ask you to share, Chris. And there's a possibility that when you picked the engineering plan or the architectural plan, that you picked one that didn't match our drawing. So let's watch what happens when we reload from. Okay, so I don't see any right now. I don't see any walls or or ceilings or anything. So let's go back to that manage links. Here we go. And it says not loaded, not loaded. So click on the top one. That's the architect. And yeah, and reload from. And which version of Revit are you using?
23.
23. Okay, so you're clicking on the 23 and you're picking open. And that's the warning that you got.
Yes, sir.
Apparently, there's only 2 of those. That doesn't seem like it should be terrible. So let's pick OK. And now it says loaded. So let's click on the engineering one. There, and then reload from. Open, yep. And then OK. Okay, I see walls and stuff now. And let's double click on the ceiling plan for the second floor.
There it is. Okay. I don't know what happened.
No worries. We still don't know what happened, but when we went and opened that manage links, we saw that it said not loaded. So whatever we did didn't take, and
Okay.
just trying it again got it to take.
Thank you. Sorry about that.
No worries. Thank you, because I hate leaving somebody behind at the beginning of class, and it makes it hard all the rest of the day on you. I'm going to go make me the presenter again. Yes. And I don't see me sharing my screen yet. Good, we're back. And I'm working on the second floor. I'm going to use the second floor working plan. So I'm closing the others. This is not what's going to go on the sheet. This is just a working plan that I have open on the screen right now. And in this plan, I can see the light fixtures and the diffusers, and I kind of see the ductwork. I definitely see the walls. I do not see the steel. So I'm going to go work on the view template, FP working floor. And on the view template, I'm going to look at the view range. And the view range is being enforced. So whatever I set this to, I'm setting it for this view and all the other views that use this view template. And it says the bottom is whatever level I'm on. So the bottom of level 1 is level 1. The bottom of second floor is second floor. The top is that same level, second floor plus 13'4". The cut plane, how do the walls show? Do they show the doors or the windows? That's depending on the cut plane. And it turns out that the steel pays particular attention to that cut plane. So I'm going to move it up to 12. I'm going to move it up to 13 feet. So is it likely that a plane at 13 feet cuts through the steel? I'd say pretty likely. So I'm going to pick OK, and I'm going to pick OK, and sure enough, there's the steel. So a cut plane at 4 feet doesn't go through the steel, and it depends a little bit on what discipline it is. Is this an architectural type plan? Is it an engineering type plan? Is it a fire protection type plan? That comes into play. The architect could say, steel schmeal, I just plain don't ever want to see it. And no matter what you set the cut plane to, the architect's not going to see the steel. I don't know that. I'm just saying that the discipline, those disciplines that are available do affect what you see and how you see it. And then the other thing is the by type. Walls participate in that cut plane to decide whether the doors in them or the windows in them should show when we show you the walls. And you'll notice that the door swings are gone because cutting the wall through at 13 feet doesn't go through the door, so we don't show the door. Same thing for the windows. So for the most part, the top and the bottom of the view range are that's the most important thing. But that cut plane decides in that range by type of object, how should we show that? And where are we cutting it to decide on that? All right, so we see the steel. I had some other stuff on here. Hangers are touchy because they're hosted by the end of the pipe, and hangers are best left till near the end. We're in good shape on all of that. I'm moving on to the one that talks specifically about ring hangers. I'm going to do the ring hangers, each one of those 4 different ways. Because of that end disc, we're hosted to that pipe, to the disc at the end of the pipe. Copy and paste it's not going to crash and burn and say it can't happen. But when we go to stock list it, it's paying attention to that original host pipe, not to the one you think you copied it to. So we discourage that and say, we gave you tools to make it easy to put them on there. That's the best way to use them. And I think I've already gone a step ahead. These 2 things are applicable to every kind of hanger, but I wanted to focus on the ring hangers first on this slide. Okay, so I'll leave this one slide up and I'm going to do a ring hanger 4 different ways, and then we'll talk about all the different kind of hangers. I won't do every other hanger 4 different ways. So we're going to do one off of a ring hanger. I'm going to just pan up here, and I'm going to put a hanger on this 1¼ pipe. To do that, I'm going to go to HydroCAD Hangers. The very first time you open hangers, it needs to go find the various families that could be used for hangers. It takes longer on that very first pick than all the rest of the times in the project, whether even if you leave Revit and come back, but if on this project you've done it, it'll be a little bit faster the first time. Now, hanger family are those 5 or 6 different kinds of hangers that I talked about. So I'm going to use an adjustable ring hanger. Most of them, the type and the name are the same, but in the case of the ring hanger, there's 2 flavors. There's the band hanger and then the clevis hanger. So I'm going to stick with that ring, or the adjustable ring band hanger. Those top 2 things determine how it's modeled or what it looks like in your model. But what it looks like and what actually gets listed for material are 2 different things. First 2 here are what it looks like, and then this hanger assembly actually comes from our stock listing program. And out of the box, the stock listing program has a couple of dozen or more assemblies of material associated with hanger. So just a little hanger tech I will represent on this one as a top beam clamp, a rod, and a ring. So there's only one little model, but we're going to get when we get a list of materials, it'll include the ring, it'll include the rod, and it'll include the top beam clamp at the top. So you can mix and match. I'm using this picture, but I'm using this assembly to make sure I get the material that I want listed for that symbol. Okay, so that's what gets listed and what shape it is. Then how long the rod is dependent here. I could just say make the rods a foot long and just type a foot in here. Or I could say hang to level 2nd floor, and I need to go 13.4 above the 2nd floor. Or I could say go find a roof or a floor above me, and the offset will be the thickness of the roof or floor. I've done some research or done this project enough times to know that the roof on the 2nd floor is about 5 inches thick. So the offset is that the bottom of that roof, well, the bottom of that roof minus 5 inches for the thickness of the roof. So having done that, I'm going to pick OK, and I'm just going to click on a pipe, and I'm going to click on a pipe, and I'm going to click on another pipe. So the hanger tick goes where I click on the pipe. I can move that. This one, I'm going to go move over to there. But when I put it on this pipe, it got hosted to the disc at this end of the cylinder or the disc at that end of the cylinder. And its actual location is measured from one end or the other. As a result, you'd be able to move this in one direction. It says I can't go that direction. That implies that it's measured off of this and the distance can't be negative. I could go in this direction kind of as far as I want because that dimension is off of that disc. Easier to keep track of if you just say, I put that hanger on that pipe, it should stay on that pipe. I just want to show you what that looks like. I'm going to go make a 3D view of this thing. That's one of those hangers. And I'm a little disappointed. That looks like my 5 inches. I should have just said to the bottom of the level and quit there. I think I was confused. I used to have the roof level and I needed to take the 5 inches off. So I'm going to say to the bottom, and the offset is 0. Easiest at this point is I'm just going to erase those. And I'm actually going to go talk about the next one. I can pick a whole bunch of pipes and tell it put hangers on all of those pipes. If you use that tool, it's the fastest, but it's not the most accurate. Every pipe that's 2 feet or longer gets a hanger on it, and the hanger goes to the middle of that pipe. If I'm interested in making sure that I list enough of the right kind of material, that thing works great. If I'm trying to instruct the installer exactly where to find the connection to the building, I should use either one at a time or intervals or crossing detail lines. But let me do a bunch this way. I'm just going to pick window, a batch of pipes at the end there, go back to hangers. And because I picked pipes ahead of time, it's going to automatically hang those when I leave here. I'm going to make that offset be 0 though, because I'm just going to the bottom of the roof. Under options is where it says, if the pipe is 2 feet or longer, I want to put a hanger on it. If it's not 2 feet, don't bother putting a hanger on it. And then when I pick OK, every pipe in that selection that's 2 feet or longer gets a hanger on it. And let's go look at 2 of these. And a good idea that the first hanger or 2 that you put on, it's a good idea to go look at a 3D view or a section view or something to know that you're communicating pretty well. Okay, so now we're hitting the bottom of that roof deck with that thing. I like it. Okay, so third way is at intervals. I can say go a foot off the end and then go every 10 feet. To do that, on the hanger tool, you go hangers, and then under options, you say auto hang along a pipe run. And I'm going to say start a foot off the end and go every 10 feet. When I pick OK, now it's I have to go back to hangers and pick OK. It's looking for a run of pipe. So it came a foot off the end, then it went 10 feet, then it went 10 feet, then it went 10 feet and went 10 feet like that. I think I'm going to go get rid of all of those hangers and then do them that last way, which makes the most sense here. So I'm just picking a window around everything. I'm going to go to the filter and say I want just the pipe accessories. Revit doesn't have a category or a family for hangers, so we cast them as pipe accessories, things that add on to the pipes. And I can believe I had 11, so I'm going to delete those. And now I'm down to pipes with no hangers on them. And that last scheme was to draw detail lines and then say every place my pipe crosses that detail line, that's where I want a hanger. So I can go to annotate detail line, or I could just type DL, and I'm going to put a detail line across there, and then I'm going to copy it from there to there to there to there and to there and to there. And if I wanted to get fancy, I could say this detail line needs to move over for these 3 lines, so I could have one on the north end of the building, one on the south. I'm not going to get that fancy. And then I'm going to go back to the hanger tool, and I'm going to say that's what kind of hanger. That is the height of the hanger. And under options, I'm going to say create hangers on a line. Do not do the pipe run thing anymore. So create hangers on the line. Then I have to go back to hanger and pick OK. And I'm going to say put hangers where that line crosses the pipes, and where that line crosses the pipes, and where that line crosses the pipes, that line, and that line. So there's hangers, there's hangers, there's hangers all across the building. Your choice whether to leave those lines or not. And I don't know whether I was being chicken by picking those lines one at a time, or if I could have just picked the crossing window across. I'll practice that the next time I go to use them. So now I want to put trapeze hangers on, and the trapeze hanger is cool in the sense that it's paying attention to the shape of the trapeze and what size pipe it's holding up and what span it's holding it up over, and it's adjusting the size of the trapeze pipe bar according to those the load and the span, and that's dynamic. So let me show it to you. I'm going to come back and go to hangers, and I'm going to change to trapeze. So there's pipe trapeze is just the pipe itself. Ring hanger and pipe trapeze is the whole assembly. They come down from the building, put a pipe, then come down from the pipe and go to the sprinkler pipe. And the hanger assembly itself is this 17A. The trapeze, I take it back. The trapeze hanger is this 17A pipe trapeze, and the hanger itself is just the rod and the ring that comes down from the trapeze bar. So it's like there's actually 2 hangers. One hanger to create something to hang from, and the other one that hangs from that to actually hang our pipe. I still want to go from the bottom of the roof at 0, and I want my trapeze bar 1 foot down from the roof. And then I'm going to pick OK, and I'm going to pick there, and I'm going to pick there, and I'm just sort of randomly picking along here like that. Then I'm going to go to a section view. Well, I could probably do it here. Here's a joist, so my trapeze has to get over to there, and here's a joist, my trapeze has to get over to there. And pay close attention as I drag this over to that joist. Watch the pipe width. So as I pull it over, you see the longer the span, the wider that pipe. So when I drop it there, I get a bigger pipe. And then I'm going to take this one and drag it back over to here.
Now, I actually need to do that process. I can't do one and copy and paste. I need to do that process for each one of them. I think I can defend that on the basis of, generally you avoid trapezes as much as you can. You'd like to find something to actually hang to. But if you get a whole run of them and you need to adjust that whole run, you can create a section that looks down that whole run. And in that section, after you've adjusted one, here's the one that we adjusted, and then I can't see the other one. It's hiding there. I'd have to turn the steel off to see the other one. I can use a line to go move those other things. I could also in here adjust the height of where the trapeze bar is. And I'm going to stick with, yeah, I think this beam is hiding this trapeze. So I'm going to go move this section up there, look in that section. And yeah, there's the short guy. I'm going to go move it down, and then I'm going to drag it over, and I'll drag it over this way. Okay, so that is trapeze hangers.
Is that sizing always based off the main being center?
Yes. If you want to get fancy, you'll have to do that on your own.
Yeah,
but
no, it's cool though.
It's sort of worst case. Then for missing lateral and longitudinal brace assemblies. So this has just been tradition for the last 45 years. We created in Hydralist a way that you can build your own hanger assemblies, and we delivered 24 of them. None of those hanger assemblies are seismic brace assemblies. There is a help video to say, here's how you could build that assembly on your own, and while you're doing it, you'll probably make some customizations to what we're suggesting. But go watch the video on how to get those assemblies in there. For this exercise, I'm just going to pick a piece of unistrut or something and appreciate that it's not legitimate for the seismic brace. But the brace itself, a longitudinal brace is perpendicular to the run of pipe and supports swaying in the direction perpendicular to that run of pipe. And that's a lateral brace. I think I misspoke. A lateral brace is that perpendicular, and then longitudinal is along the axis of that pipe, so parallel to the direction of the pipe. In both cases, we're going to model the attachment to the pipe, the brace itself, the piece of pipe, and then an attachment to the building. So over here, I'm going to go say there's a main, this is a beam in here. And I want to attach laterally to that beam to keep this thing from swaying back and forth. So I'm going to go to hangers, and there's actually a separate segment of the dialog box for this, for a brace. And I'm going to make the brace be a lateral brace that's attached on the top of the pipe. There's also a lateral brace that's attached on the underside of the pipe. I'm going to use over the top most of the time. And then the calculation of the strength is based on 30 degrees to 45 degrees, 45 to 60, 60 to 90. I'm going to put it at a starting point of at 45 degrees. And I'm going to use, again, a hanger assembly that I don't have legitimate for seismic braces. So I'm just going to use this angle iron thing. I want to hang to the bottom of the deck, and the offset's going to be 0. And then I'm going to pick OK, and I'm going to pick right near that beam. And that put that brace on there, which seems extremely long. I'm thinking I must have done something wrong. I'm going to delete that and just check my figures here again. Brace to the bottom of the roof. I thought that said 0, but it said 9 feet. So maybe I typed on the 9 when I thought I was typing on 0. So I'll redo it with 0 in there, and I'm going to pick on that pipe. And then I'm going to move this section down so I can see what that looks like. I'm going to make the section not be crowded with too much other stuff. And then if I look in that section, there's that seismic brace. There's a two-way arrow. I think I'd rather go in to the right rather than to the left. And there's a two-way back and forth arrow that I don't see in this view. So I'm going to go back to the plan view, and there's no. Where's Waldo? There he is. So that's the switch it to go the other direction. Then I'm going to look in here and say, yeah, that's not terrible. However, I could get away with attaching to the bottom of that beam rather than going all the way up to the roof. And I could probably afford to make it even shorter and still be over the 45 degrees. So when I made those two adjustments, if I look at the properties over here, it says that's at a 56-degree angle. Gee, if I pulled that just a little bit further this way, now it's at a 63-degree angle, and I could make it smaller for being stronger, for being at a shallower angle to the roof. So I'm happy with that. I'm going to redefine it as, where is he picked now? He's lateral over the top of the brace at 45. I'm going to say, yeah, now that I've adjusted it, I'm going to record it as at 60 degrees. And when I do my calculations, I'll know to use 60 degrees. Similarly, I could put a longitudinal brace on there. I'm going to go back to hangers. I'm going to go to braces. I'm going to go to longitudinal. Over the top, there's no under the bottom. I'll start out, well, let's start out at 60 degrees because I'm probably going to go to that same beam. 0 feet, I think I could go to minus 1'6". That's kind of a guess, but it's about what I just learned. And I'm going to put that on there. And that brace is going north. I'm going to cancel and then do a file save as, which I should have done a long time ago, like when I first started. And I'm going to make this be end of day. Okay, and then I'm going to turn this one around so it's attaching to the bottom of that beam again. So I got to wait for the save to finish. There's the two-way arrow, much easier to see. And I'm going to put a section so I can take a look at that. Doesn't have to be so deep. And then we'll go to that section. Oh boy, I was just plain guessing, but that worked out pretty good. I'm using the arrow key. Man, that worked out really good. So there's 60 degrees, and there's I'm hitting the bottom of that beam.
Can I ask a quick question?
Yeah, go ahead.
My sections are still colorful. I forgot how to make it back to 2D. Is it a view template?
So down here in the lower left-hand corner are two settings, whether you're doing fine, medium, or coarse. Fine and medium are like single line things, and coarse, I'm sorry, medium and coarse are single line things, and fine is this detailed. The one next to it says hidden line or shaded.
Okay.
And I'm controlling that with the view template, so it's locked at hidden line. That's the 2 lines with just the line work. If yours isn't locked, you can go ahead and pick on hidden line. And if it is locked, you can go over to the view template and tell it, I want to pick that model display myself.
Okay.
And then this will be lit up.
Great. Thank you.
Good deal.
So now that I'm at that step, it doesn't allow me to manually select the mounting end of the structure on these. You know, if I click the whole trap bar, it's an item as a whole with no adjustments in the 3D view.
3D view is an unlikely place to adjust that. I'd do it in a floor plan or a section view.
Oh, okay, that's right.
Um,
Okay, thank you.
Yeah. Okay, so riser clamps, just for the fun of it, that's on a vertical pipe and it's its own type. I do have, it's usually used more often in a high-rise building, but we do have a second floor here, and in the second floor we've got a pipe going through the stairway. I've got a section view that ought to see that pipe in the stairway. There it is, and I want a riser clamp to keep that from falling through the floor. So I'm going to go back to hangers, and the hanger type, I'm going to pick riser clamp, and the assembly I think is 19, 18, 19 is a riser clamp. Bottom of the floor, no, I'm just going to put it at level second floor 0. Under options, though, I have to say, allow me to put this on a vertical pipe. And then I'll go back and pick OK, and then pick on that pipe. I don't see my hanger. I'm going to try that again. Riser clamp, 0 feet above second floor. Pick OK. I am stumped. One last time. Options, include vertical pipes, yes. Go back to hangers, pick OK. Okay, so I had to have that on, allow me to pick on vertical pipes. There's no good way to align this. I just have to like drag it down with that 2A arrow. And I think the installer can figure out that it wants to match up with the floor, not to let it to leak through there. While I'm in the same view, I can put a pipe clamp on my backflow preventer, or a pipe stand. So I'm going to go back to hangers, and there's another slide for that, pipe stands. So I can go back to hangers. I'm going to dial in pipe stand. I'm going to dial in pipe stand for the type here, and level ground floor. Go 0 feet off the ground floor and pick on that thing. And I usually find myself putting more pipe stands than I need because they're so much fun and they look cool. And so long as I'm putting them and they look cool, let me go back to the ground floor and find a section line that looks at my riser manifold. And I could put a couple of pipe clamps on, riser stands on here. Good. Pipe stands on there. Okay, we got our hangers. We're ready to get a stock list for this stuff. Questions on hangers before we go on? Then The next 10 slides or so relate to creating a stock list. First thing is to set the accuracy of the stock list. That comes from the project units, and I'm going to set it either to quarter or half. So on the manage ribbon under project units, there's a thing for length, and if that's set to nearest quarter, the stock list will be to the nearest quarter. If it's set to nearest half, we'll get that. So I'm going to go set it to the nearest half. Manage project units. There they are. And length, and here I could say nearest quarter or nearest half. If you said nearest inch, I think we're doing the nearest quarter. If you said nearest eighth inch, I think we're doing, 1 inch, we're going to go to the nearest half. Half inch, we're going to go to the nearest half. Eighth inch, we're going to go to the nearest quarter. We're two flavors, half or quarter. So pick one of those two. And then I'm going to run setup. Each of the menus, we did this on the calcs, and we'll want to make sure we do it on the listing. They're the same looking button. They work the same, but they do different things. So if I'm getting ready to list, good idea to run the setup button. Really only once per project, but it doesn't take long enough. A lot of people get in the habit of just, oh, I'm getting ready to list. Let me run setup. No harm in that. Now, I can list the entire project like we calculated the entire project, or I could list just the 3 branch lines on the north side of the second floor, or I could list just the piping on the second floor itself. We used system dividers before. That lets me do a walker and it stops at that system divider. But if I want the stock list to stop listing, there's also a stop sign that says, do this pipe up to the end of this pipe, but don't go beyond that. And it puts a graphic symbol, that stop sign. And if you change your mind and you want to get rid of it, there's a button that says delete stop sign. If you simply delete the graphic, the stop sign is still embedded in that pipe. The end of that pipe was labeled, don't go past here. And the graphic is just a reminder of that. So use the delete stop sign if you put one on and change your mind about it later. I think I'm just going to mention that. And as we proceed, I can decide whether I want to partially list something or not. I'm going for a list of the second floor. Now, in HydroCAD for AutoCAD, we were very meticulous about saying main A starts right here at the bitter end of this pipe, and it goes that way. And main B starts there and goes in the direction of that pipe, and main C, and then weld line 1 and weld line 2. And I felt like that was unnecessarily tedious. So we built the automatic listing feature into Revit, which says we can find the bitter end of a pipe and say start there and go that way. So that tagging gets done automatically. To give it a start, however, we use this listing tag direction start point, which just says, of all the pipes that we've selected with the walker, list them all, but start numbering them in the vicinity of this start tag. So I'm going to use what's shown here on this diagram to put the start tag near the riser manifold, put a system divider at the groovelet there, and then when I do the walker, I'll get all of the second floor stuff, but the names will get labeled A, B, C, starting at the bottom of that thing. So I'm going to go back here, and I'm already in this section view, so I'll just remind you how I found that. in the project browser, if I went to the ground floor, not the ceiling plan, the ground floor plan, there was already a section line looking at that riser manifold. So I opened up that section and that got me here. Now I'm going to go to Hydra list, tag direction, and I'm going to say direction, section, direction, say that 3 times fast, section, direction, marker. So I'm clicking here, which is in the vicinity of the start point of the stock list that I want. I don't have to actually put it on a point. It just says, oh, I found the dead end here, or I found a dead end here. And I found the dead end at the far end of the cross main on the second floor. Which one of those is closest to this tag? I'll start tagging there. Now, this blue thing showed up, and whenever you put something in a view, it goes on a work plane in that view. This is really sections that this happens to, and it switches the work plane to the vertical plane defining this view, and it turns it on. If that bothers you, and there's no harm, there's no reason to do anything about this, but if it bothers you, go to architecture, and over here is show the work plane. Just turn that off and the blue goes away. All right, so we're gonna put that tag there. I'm gonna put a system divider there in just a minute, and let me try walkering this pipe that goes up to the second floor. So I'm doing the walker by typing WW. I'm picking on that pipe, and it selected the entire piping system. If I made this fitting be a system divider, then I could get that. I'll turn it on and I'll turn it off. If I made it a system divider and did the walker again, I could then select everything going up to the second floor, and everything on the second floor is selected also. I think if I open that view, I'll see that. Or if I had the view open and I did it, let me go backwards here. I'm going to do the walker on the second floor piping. Oh, it was selected, but I'm doing the walker on the second floor piping, and I'm going to go open that section again, and you see it's selected down to there. Okay. The next topic is not necessary. I'm taking the system divider off of that I already put it on. I'm just taking it back off. The next topic, though, is about not this project. This project's too little to really require this next topic. However, you will work on projects that are so big that you're proud of yourself for adding so much piping to that one project. And then one day you wake up and you go to delete a coupling and you have to wait 30 seconds or something. And then you go to draw a pipe and you have to wait another 30 seconds. That becomes an UG situation. This next topic is a way to avoid that and or to fix it after it's created. Revit has a built-in habit that every time you create a pipe, it says, oh, that pipe could affect my neighbor, and my neighbor could affect his neighbor, and his neighbor, his neighbor. So I'd better go check all through all of those connections and find out what was affected by your just doing this one pipe. Once you get 2,000 pipes, that takes way too long. If your piping network is divided into actual physical separate systems or separate piping networks with a physical gap, then that automatic calculation of neighbor to neighbor and neighbor will stop at those physical connections. So that's one way to fix that problem, is actually break the systems with a physical gap. But gee, we spent all that time trying to get it all connected. It feels bad making a gap. Hydratech created a Hydrotech system divider fitting, which is effectively creating a physical gap that the walker can go through, that um, the whole model is still connected and all of that, but it interrupts that Revit calculation. And so those systems remain individual systems. I'm going to insert that thing. So we're going to separate the systems into 4 separate systems. I'm thinking right now it's all one system. And if I break it into 4 separate systems, the performance will be theoretically 4 times better. I think it's not all of 16 times better, but it's more than just linear. Like the more pipes you add, exponentially the performance gets worse. So when you break it into smaller pieces, exponentially it gets better. So I'm going to propose the bottom of each of those risers as the breakpoint. So I'll have a lower level system, a ground floor system, second floor system, and a supply system. This is going to the definition of a Revit system. They've got cold water piping, hot water piping, drainage piping. Those pipes might all like the cold water and the hot water are all tied together through a water heater. So they're all one system, but Revit intends for them to get broken up into separate systems. As we were drawing our pipe, we were telling it that our pipes were all fire protection wet. When we used the spacing and layout tool, I didn't make a big deal out of it, but it said, what system type do you want to make these sprinklers a part of? And if I go interrogate that now with the Revit system, reporter, the system browser, I can see whether I have 1 or 2 or 17 systems. So I'm going to go to View, and under User Interface, if I lost my Properties bar, I could get the properties back. If I lost my project browser, I could get my project browser back. If I played the country music backwards, I could get my house back. I could get my dog back. I could get my truck back. But right now, I want to get the system browser back. And this system browser is a list of electrical systems, mechanical systems. There's an unassigned system, and under piping, there's one fire protection system. So right now, everything happened to be all tied together. It's all one system. And that's what eventually can get too slow. I'm going to go put a coupling in here. How about CP for coupling? Why can't I, CP, okay, manual coupling. I'm going to put a manual coupling there, there, and there. And then my experience is if I erase those couplings, Revit doesn't know to automatically put those things back together. So if I do the walker now, that's a bunch of pipe and it can't walk through that gap. And then on the system piping, remember I opened the system browser, and when I did, I kind of got some extra menus here. Under system piping, I'm going to say divide system. And it says there were 7 physical networks. Gee, I thought there were going to be 4. And he says there's 7. It didn't take me long to find out where the other 3 were, but just open quiz question. Anyone guess why I've got 7, not 4? You'd have to have a really sharp eye and a good memory. On the ground floor, when we were doing our coordination, I'm going to go back to analyze, piping, show pipe disconnects. Any chance, Josh, you remember that I blew that off? I moved the system up, I moved it up, and it said, oh, you're going to disconnect. And I said, yeah, go ahead.
Yeah, I was gonna guess it was bringing in the site plan system or backflow as a zipper system, but I do remember that.
Now, what's the chances you actually remember this? Slim to none. So I just wanted to point it out. I'm not going to say, oh yeah, I remember, so we're going to go fix that and get 3. I'm going to delete it and make 7 systems. And say, yeah, I was puzzled, but damn the torpedoes, full speed ahead. So I'm going to go to click on a system, and then I'm going to say divide system. And it says I'm going to make 7 separate systems. Okay, go ahead and do that. Okay, and they're called, they're very, very cleverly called wet system sub 2, wet system sub 3, 4, 5, 6, and 7, wet system number 1. And if I click on them, there's the supply system, there's second floor, there's the ground floor, there's, which one is that? Let me look around. Maybe if I had a 3D view of everything, I'm going to take this squiggle 3D and delete it. I thought I could delete that. There. And then I'm going to go to View, Default 3D View. And I did that so I could get a 3D view of everything. I'm going to make this System ISO or FP ISO. And then in this FP ISO, I'm going to make the view template none, which means I can turn off the Revit links. And I'm left with my sprinkler system. And in here now, if I click there, I'm going to make this be fine detail and click there. I could even rename that second floor. Good. I click this one. That's the ground floor. I'll click this one. And that one's only got like 1 head in it. Oh, there it is. So that system is part of what got broken when I was moving that thing up and down. For now, I'm just going to take I don't know what I'm going to do with that. I guess I'm going to get rid of those fittings. And then this system is this guy over here. I'm going to get rid of those fittings. And this system is the lower level, so I'll rename that lower level. Second floor, lower level, ground floor, which is this one. We got that guy. We got that guy. This guy. I want to get rid of those fittings. And then this system is that supply. So I'll rename that supply. Okay, so I've got kind of 4 good systems and 3 orphaned systems. Let me go to the ground floor. That's where those 3 orphaned systems are. And I'm going to get rid of this pipe and this pipe. And then I'm going to take this pipe and connect it back to that pipe. I should be able to just grab the end of it and drag it there. I should be able to, and I didn't. Let's try it again. Okay, so I've got one pipe going past those 3 orphans, and now I can just drag this pipe onto this one. There was not enough room. Okay, so I'm going to cancel that. This guy is at 9'5", and this guy is at 9'6", and that's what caused that problem in the first place. I don't really have enough room to go up, over, and down. I'm going to just make that 9'5", and then tie him into the side. And they'll just have to be careful when they're trying to relocate that head. And then and maybe I can swap that out for flex heads. And I'm going to make that 9'5" and connect that into the side. And I'm going to make this 9'5". Come on now. And pull him into the side. Now, do you see what happened when I connected that pipe into that system? It became part of that system. So now there are just 4 systems. That's pretty cool. And if we go back to our ISO, why you give me a hard time about that?
Yeah, Alan,
Yep.
why does it look like it cut it back, cut those pipes again, like it was before?
Is this, why does it look like it cut them back? Or did I miss it? I'm not sure I understood your question.
Remember they were orphaned,
Yes?
and there was a line that was going, cutting them in half or cutting the pipe.
Let's go back. Okay, like this?
Yeah, well, wasn't there a line before that was like, yeah, right there?
Well, in the 3D view, I saw those things and I erased those extra fittings. And then I erased these 2 pipes and I put this pipe back together with that pipe. So it became one great big long pipe without these guys connected into it.
Yeah, gotcha.
And then this one's still not connected into this long pipe now. So I just took its end and dragged it onto that pipe. I did undo, so I wound up with the branch line at 9'5" and the arm over at 9'6". So I said, that's what he's complaining about. I'll make it 9'5" also, and then I could drag its end 9'5" onto 9'5", and I put a pipe up there.
Okay, I see what you're doing now. Thank you.
Okay, so I still have these 3 darts that says the riser's not connected into. And I'm gonna show you the problem here. I have 4 systems, and I'm gonna take this pipe and reconnect it to that pipe. And now I've only got 3 systems. It said, oh, that's connected. I'll put it back together. So if you physically separate it, you get your performance back. As soon as you put it back together, the performance goes to hell again. I'm going to do undo to get 4 systems back. And the trick or the gimmick is I need a thing that will allow me to have those connected so the walker could go through it, the calcs could go through it, the listing could go through it. They need to be connected, but I've got to prevent Revit from trying to merge those systems together. And the tool for that, or the trick for that, is this fitting called HydroCAD System Divider Fitting. It looks like a coupling, and it behaves very special by saying, do not go put these things back together. I'm holding them together for every other purpose, but I don't want the systems to get put together through this fitting. So over here, I'm going to go make room to put this on. I'll get some room there. I'll get some room there. And I'll get some room here. And then I'm going to go find that fitting. It's going to be under families. And under families, I'm going to go to close up this long list of annotations. And then I'm looking under pipe fittings. And under pipe fittings, about 2/3 of the way down is that HCAD Hope I didn't go by it. I did. System divider fitting. And you have to, that's the name of the fitting, and this is the type. Sometimes there's 2 or 3 types for the same fitting. This one has only 1 type, and I'm going to take that and I'm going to drag it over here and park it there, park it there, and park it there. And then I'm going to put this back together. But watch what happens. I have 4 systems. If I click on this and say to this, connect that, I think that went on there backwards. I'm going to take this and pull it off of there altogether. No.
Alan, I noticed when you try to set that coupling, sometimes you kind of got to hover close to it to seed it. Is that correct?
Yes, it is. And for that purpose, I'm going to use that to this, connect that thing. I'm just going to put one of these there. I'm trying to put it on nothing. Okay, so I put it out here in space. I'm going to rotate it. And then I'm going to copy it from there to there to there. So the coupling actually has, do you see those 2 little dots? One is to connect the pipe on the bottom half, and one is to connect the pipe on the top half. And they're so close to each other, they're a real nuisance to figure out which one's which. And I thought I was getting lucky, and I just said drag this onto here. But if I click on this pipe now and I say to this, connect that, it connects the 2 connectors that are pointing at each other. I don't have to squeeze way in to squint and find out which one's which. To this, connect that. To this, connect that. And now to this, connect that. To this, connect that. I picked on the wrong thing. Try it again. Click on the fitting. To this, connect that. Try it one more time. I've already clicked this. Now I'm saying to the thing I've already selected, connect that. And the command keeps going, so I can say to that coupling looking thing, connect that pipe. Okay, and when I did that, if I do the walker walks through everything. I could run a calc, I could run a list, I can select stuff. I'm picking everything, but I didn't wind up sticking those systems back together. They are still unique systems. And I can go add pipes to this, I can add pipes to that. They will become part of those individual systems. And the performance will stay good like it's supposed to. I'm going to just go ahead and collapse these using DP for delete pipe. and I'm going to delete the pipe between that groovelet and my system divider fitting, and there and there. Okay, so its purpose is to say there's a system on one side of me, there's a system on the other side of me. Revit, just leave those divisions in place. Don't be trying to put them back together and making the performance go bad again. Okay, up to 1,000 pipes or so, I'm saying this is a nice thing to do, but totally not necessary. 10,000 pipes, and you're really, really, really going to need to do this, or everything will be gruesomely slow and life will not be fun. So, if you do it early in the process, your performance will stay good. If you wait until the performance gets bad, takes a little bit longer to break the system physically and then say, divide system, then the performance gets better. But don't just go put it back together. Put these things in before you put it back together. Okay. This is one of those things I tell you now, you believe me later. It's like, yeah, that seems confusing. And do I really need to do it? And the answer is up into 1,000 pipes, probably not. Hokey doke. In our case, and this slide I'm just going to mention, but in our case, we had too few systems. We only had we basically had one system, and we divided it up into 7 individual physical systems. And then when we put those system dividers in, it made it easy for us to relabel them. We've had in the past the occasion where like every sprinkler somehow made its own system, and you had the reverse problem. There wasn't too few systems, there was too many systems. If you wind up with that, then in the system browser, you can click on these systems and you can say delete, and that'll delete the systems. I'm going to do it so that you see all of that winds up under unassigned now. There are no piping systems. And if you redo a pipe, I'm going to Control C, create similar, and I'm about to draw a pipe, but I want the pipe to be in system type fire protection wet. Then when I draw that pipe, it becomes part of that system, and that whole system becomes fire protection wet. And you could relabel that. You could give it you could take that system and rename it now, supply. So one pipe added to an undefined system will give the system a definition, and then you can rename it. I'm going to undo to get back my 4 systems.
Well, never mind.
And the reason for that is you wound up with lots and lots of systems. So they're physically connected. I went just a little bit too far. Is there a redo? A redo. Okay, so we've got our 4 systems back. Okay, so I took one system and I physically broke them up and I divided it into individual systems. If I have too many systems, I can delete all the systems, and then when I draw a pipe of fire protection went into one of them, it's going to make all the pipes connected to that be part of that system. Okay, before we're fixing to run a stock list pretty soon here, but before we do, I just want to look at it and say, does what I modeled make sense when I look at it a different way? We've been looking at it in in a ground floor, in a second floor, in a lower level picture, and I say, yeah, I see pipes. That makes sense. I got it. I see what the pipes are about. But if you look at the pipes a different way, namely through a schedule, um, it's often very easy to see something that um, was not what you intended. And I don't know better than just showing you this, how to explain this. I'm going to go to a schedule for pipe size and type. And in here, if you see half-inch pipe, that's where you did one of those arm overs and it made the drop half-inch to connect to a half-inch sprinkler. If you see 3/4-inch pipe, it's potentially that also, but the head that you're connecting to is a 3/4-inch pipe. And not out of the question that you maybe had some sensing line pipe or something like that that you wanted to be careful that you wanted to be 3/4. So be careful about just randomly changing it to 1 inch. So I have 176 1-inch arms to welded lines. Well, I got a lot of drops, a lot of pendant heads, and every one of those pendant heads, or most of them, have an up and over and a down. So if I had like 70 of them, I'd wind up with, or 60 of them, I'd wind up with 180 of these things. So that makes some sense. I've got 6 pipes that are lines threaded. Jason, can you picture where those 6 threaded branch lines might be? I caught Jason with his mic muted. How about you, Josh? Can you picture 6 threaded pipes somewhere? Or did we do that by accident?
Sorry, I got background noise.
So I'm looking at these 6 threaded pipes. Is that oh yeah, I know where those are? Or I wonder if that's a mistake. I wonder if those should be welded also.
Will it show you where they are on the project? Can you mark
That's a
them right?
great question. So if I click here and I click on highlight in model,
Got sprigs or something?
yeah, I'm not going to pick show. That's going to go look for another view. Look at that. They're highlighted in this view. So on the second floor in the mechanical room, I had some uprights and I did that on 1-inch threaded pipe. And I had this electrical or communications room and that was on 1 inch. That makes sense to me. It's like, yeah, I don't need welded lines into those. They're just 1 or 2 heads. Make sense?
Yep.
Okay, so back on the schedule. 147 welded branch lines, 1.25 inches. That makes sense. Where did the 2.5 come from, Josh? We'll use the same trick.
Was that your main?
I'm going to use the same trick. Highlight and view. It says there's no open view. Okay, go look for one. And then it found one, so I'm going to click here. Remember we made a grid and we made the far main be 2.5, and then we ran that upstairs to the lobby? Maybe?
Alan, and just so you know, when I click on show highlight and view, I get like 8 different window pop-ups telling me, asking me if I want to show in multiple views. And I'm having to like click through like 10 different windows to
Yeah, just close, like the very first one, just say, don't,
open.
you just say close. Like,
Okay.
he says, because that pipe shows up in lots of views, right? But you only need to see it in one. So as
Okay.
soon as it says, do you want to see another view? You say, no, I'm good with this one. Okay, so we're good with where the 2.5 was. Does that ring a bell for you now, Josh?
Yeah.
So back to the schedule. I'm going to break this up one more way, though. This is all the pipes in the entire project. Now I'm going to close my system browser, and in my properties for this schedule, I've got fields, and the fields are the count, the diameter, and the type. I want to add a field for system. Here's the system name. Add that to my schedule. I'm going to put that at the top of the list, and I'm going to subtotal. Where is subtotal? Over here, sorting and grouping. Right now it's doing by diameter by type. I'm going to put type on the bottom. I'm going to put diameter in the middle, and I'm going to put by system on the top. And then OK, and put a footer after each system. So same stuff, but I've got 1-inch pipes on the ground floor, and I've got 1.25-inch pipes on the lower level, and I've got 1-inch pipes on the second floor, and I've got just 4 and 6-inch pipes in the supply piping. That's an added advantage to doing those systems the way we did. Alternative to this, if you get lost in the Revit systems thing, I used the property system name, but the pipes can be assigned a property called HCAD system, and you can populate that and sort by that. The advantage to the Revit system is that automatically, when you draw a new pipe and connect it into the second floor, it becomes part of the second floor system. The Hydrotech property HCAD system would require you redo the walker to get all those pipes on the second floor, and then make sure you've filled in HCAD second floor for that selection set. Okay, questions on that?
I don't have any questions on that, but for some reason I haven't been able to master delete pipe command and have it work properly. Do you mind taking just a quick second to?
Absolutely not.
I'm all caught up except for that one part. So
Okay, so delete pipe works at least 3 different ways. If you have a pipe selected and you pick delete pipe, it's going to delete that pipe and try and take the ends of it and put them back together. That's one way that delete pipe works. My least favorite, or the one that I use least often. A second way that it works, you don't have anything selected and you pick delete pipe. If now the thing that you pick is a pipe, it depends on whether you pick the first end or the second end. If you pick near the first end, I don't propose picking at the end, because at the end there's a fitting. So near the first end, the pipe will disappear, the fitting at the first end will stay put, and the fitting at the other end will come to meet it. The third way that you can use delete pipes is have nothing selected, and when you pick delete pipe, don't pick a pipe, pick a fitting, and then pick another fitting. The pipe between them will go away. The first pipe picked will stay put, or the first fitting picked will stay put, and the other fitting will move to match it.
okay, thanks. And that's the last one's the one you had done on the riser, I take it?
I do believe, yes. I picked
Okay, so
the groovelet, and then I picked that divider fitting, and the pipe between them disappeared, and the divider fitting moved down to the groovelet.
yep, nice and easy. Thank you.
It is easy once you realize that it has 3 different behaviors. If you don't realize that, it's going to fight you, because you think it's doing one thing and it behaves differently. You didn't realize there's 3 different.
Yeah, I guess compared to HydroCAD for AutoCAD, I'm missing the command prompt quite a bit here.
Generally, it's hiding down in the lower left-hand corner.
Yeah, but like you said, it doesn't indicate the 3.
Right. The three different
options
ways
about.
that you can use it.
Yeah.
Fair enough. And thanks for the input. I will take that to heart. Maybe we could get a prompt that said, you got 3 starting points here. Tell us which one. And then if the first thing you pick is a pipe, you're probably done. But if the first thing you pick is a fitting, we could prompt you to pick the other fitting. So, which is a blind spot for me. I love the way that command works. I know how it works. It doesn't even occur to me to look for the command prompt. So I appreciate your input. I'm moving on. So now if I do the walker, I think it's going to go everywhere, but I want the walker to stop at that system divider. I'm going to go try that out. Let's go find the section at the riser manifold. I've got too many tabs open, so I'm going to click on the close all the other tabs. And then I'm going to do the walker and pick on the second floor. And sure enough, it's going over the whole world. So I'm going to escape, escape, escape. I'm going to pick a window around those 3 system divider fittings, and I'm going to check mark system divider. So they're not only keeping the Revit systems apart, they're giving the walker a place to stop. So escape, 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 WW for walker, pick on the second floor pipe, and it walks everything up to and including that system divider fitting. So create a hydro list. We're going to walker the model to be listed, and then we're going to start the process. I got to remind you that we put that tag start direction so that we're going to tell it list the mains A, B, C, D, list the lines W, 1, 2, 3, 4, list the threaded lines L, 1, 2, 3, 4, and that counting will start at nearest this thing. It'll start at the end of a pipe nearest this thing. So I've done the walker, and I'm going to go to Hydra List and Auto Stock List, or Shift A. And that says, okay, we're fixing to do a stock list of all the piping you've selected. And we have to click through all of these tabs on the left here. The first one says make a stock list with the job name the same as the project name, and I'm going to give it an area of second floor. Okay, and it's going to get saved in the same place as the project I'm working on. And that's it for there. Then I'm going to go to welded mains. I'm going to sneak through here and say this is probably set up with none of these filled in yet. So when you click on welded mains, on the left it says of all the stuff you selected, there are 4 different kinds of pipe, modeled pipe. And of all those 4 different kinds of pipe, I want the mains welded to be selected to be listed as mains. And I want the mains to start with section ID space A. I want it to use schedule 10 pipe. I want it to use a color code of red. And this is much less, this was very, very, very important in Hydrotech for AutoCAD and much less important here. But it says when you see 3 pipes come together, treat them as a firelock T. When you see 2 pipes come together, treat it as a firelock elbow. But if it's a reducing T, then treat the outlet as a threadolet. The difference is that in HydroCAD for AutoCAD, we kind of counted on this sort of default set of instructions. And then we put little blue families on top of all the special cases. Those were override fittings. In Revit, those override fitting definitions are mostly already built into the fittings themselves. I'm going to I guess I'm going to just say that, and I'll show it to you later. But this becomes the fallback. But the primary thing is if you drew a groovelet, built into the groovelet is an override that says list me as a groovelet. It doesn't matter what this default is. If you drew a pipelet, there's an override in the pipelet itself that says list me as a pipelet. So those things mostly take care of themselves. Okay, and we've said use the pipe lengths as cut lengths. In AutoCAD, there are no takeouts. Everything is drawn as center to center, and the takeouts are part of the listing process. In Hydrotech for Revit, we started out with that so that you could sort of take that old experience and apply it to this. But as we further developed those modeled fittings, a pipelet looks like a pipelet, a groovelet looks like a groovelet, and it has very accurate modeled takeouts. So I'm going to use check mark here to just say I'm fixing to use the takeouts that are built into that model rather than wait for the listing process to look them up and apply them. All right, that's welded mains. I'm going down to welded lines. I'm going to say use W1, W2, W3 for labeling the welded lines. Use Schedule 10 pipe, make them red. And again, there's overrides built into the fittings themselves, but if one's missing, use this generic fallback position. It says firelock elbows and T's with threaded pipelets. And again, use the cut lengths that are built into the model, and the piping that was drawn with lines welded wants to be treated as welded lines in the stock list. Then I'm going to go to threaded pipe, and I'm going to use L1, L2, L3 for the threaded pipe. I want to use cast iron, Schedule 40 pipe red, and cast iron lines, cast iron with grooved couplings. And there's another one for thread couplings. And again, that's if the coupling itself doesn't have built into it a direction. And anything I drew with lines threaded, I want to be treated as threaded pipe, and anything I drew with arm overs to welded lines, that's still threaded pipe. I want that treated as threaded pipe. There's next to no setup for the hangers, just whether you want to report them in inches or feet and inches. And this excluded pipe, by default, will always exclude nothing. But later you would be able to draw an entire system existing and then add new pipe to say threaded lines new, welded lines new, or whatever. And you could exclude all of the existing pipe and create a stock list just for the new pipe. That's virtually too much work in HydroCAD for AutoCAD. The only way you could get those branch lines that for a fit up job, all those little diagonal lines connecting heads, is to go put a line tag on every one of them. And by the time you do that, you might just as well write out a list. In here, though, you could take your existing plan and then just create a new pipe type. Just duplicate the arm overs pipe type and make it arm overs new. And you could exclude all the existing pipe and just create a stock list of the new threaded lines. And then finally, under process options, there's nothing in here you need to change on a regular basis. We might come back and talk about wizards, but I'm going to say you can pretty much get away with whatever's there. Just leave it and pick OK. So I'm about to pick OK. Should I wait and see if someone maybe got behind or wanted me to go back to something here before we leave this dialogue? Okay, then I'm going to pick OK. I'm going to take a deep breath. It read my model, it created a stock list, and it opened it in the HydroList program. I'm going to
Hold on, Alan. do you mind going back a couple steps? I'm in the setup and I'm hitting OK and it says please. Oh, okay. Browse. I need to pick a browse location. Okay.
Okay, yeah. So I didn't do anything with that. By default, it was going where my project was, but perhaps by default, it's trying to go somewhere on my disk drive that's not on your disk drive. So just pick a different place for that. Let me know if the continue gets you in here.
Gotcha.
Is good, or you need a minute?
I'm good now.
Okay, cool. So heading information just has a default job number. I could put 1, 2, 3, 4 in there, but it has a default name that says second floor. I got a little too wordy, so I ran out of space. It's got a date and places you can fill in more stuff here. I'm going to go to the mains, and I've got a main A, and there's an A point 1, point 2, point 3, point 4. I'm not convinced that this labeled the stuff the way I expected. A.1 is 0'6", and then 0 feet and a groovelet going the other way, and then 6'5". That doesn't sound like it's starting at the riser. That sounds like it's on the cross main. A2 has another groovelet. A3 has one more groovelet, and then A4 has a groovelet, a pipelet, a groovelet, and then A5, 6, and 7 are all just groove pieces with no fittings on them. These pieces sound more like the piping down on the ground floor, coming off of the riser. So when we get back, we'll go see which ones are which. But the fact that there's no whammies here, there's a 12-foot 0.5, that should probably be 12 feet. There's 12 feet, and then there's a bunch of short pieces. That looks pretty good to me. If anyone would anyone like to complain about GRPOL, or can you all recognize that as a groovelet and just plain old POL is a threaded pipelet? Speak now.
I don't have anything on that, but mine did come in the correct order. Is that
That's a wonderful thing. Walk with pride, my son.
okay? So no
You
problems.
may have been on the second floor plan when you started the list. I was in the section view when I started the stock list, so it might have found a better place to start from the view that you were in when you started.
Okay.
I'm not gonna die over this, but I think I'll go check it out. I'll fuss with it once before I leave it this way. My advice over here is run the stock list. You have to fill out the dialog box like we did. And then when you're done filling that out, you get the actual stock list. And it's a good idea to look it all over. Don't go making changes, but look it all over and say, yeah, it all looks good. Or, gee, the numbering is backwards. So I'm not going to go try and fix it in the stock listing program. I'm going to go at least do battle with it by making a change in what I did in the drawing and coming around again. So I'm looking for sort of big problems or an excuse to rerun the stock list. And then when you get back, you pick return to Revit, and that's going to put listing information into the drawing, and it's going to put little tags to remind us of what it did for the numbering. So I'm on my way there, but let's take a look around first. Line W1 is the first welded line. I'm not sure where that is, but it's got 1.25" pipe with one 1-inch pipelet on it. W2 is probably one of those whole welded branch lines. It's got 12 feet, almost 12 feet, 12 feet, 12 feet, 12 feet, and 1-inch welded pipelets. One for fitting position is pointing up. 3 is pointing down. So I think these are up, over, and down, and this one is down, over, and down. and they're all 1 inch because of the arm overs being 1 inch. Okay, so I've got a sense of where that is. It's one of those long branch lines that goes across the whole from the left to the right of the second floor. W2 has got a 12, an almost 12, 12, 12, 12. So mostly the same thing. W3, mostly the same thing. W4, mostly the same thing. W5, mostly the same thing. And then W6. So it's like there's 6 of those long branch lines. I'll go look when I get back and verify that. And all of them have got 1 inch pipelets for our arm overs. And then under branch lines, I've got L1, which is just 1'9" and 6 feet. I think this is the one that goes up and over into that communications room. It was the threaded pipe that we saw. W1 is just short pipes. I'm thinking that's the return bends, the arm overs, and the drops. W2 probably more return bends and drops. W6 is return bends and drops, but it's got this reducing T and this reducing elbow. I'm saying that's the threaded pipe coming off of that north branch line. Hangers came out red. When I put in the longitudinal braces and the longitudinal brace and the lateral brace, I just picked a hanger assembly, any assembly, because I didn't have one specifically for longitudinal or lateral braces. And it says I don't know what to do with that. I could swap those out. I'm not going to make any changes now, but I could swap those out for some other hanger assembly that wouldn't yell at me, or I could delete those two and list them separately. And then finally, under miscellaneous, I've got rigid coupling, rigid coupling, rigid coupling. It knows that this thing's that commercial riser, but it doesn't know the part number for it. So I know what I need. I just don't have a Hydrotech part number for it. And then this is that butterfly valve, and it knows exactly what that is. And then this is the caps, the Firelock T, the Firelock 90, some more rigid couplings, another cap, and then the sprinklers that we used. So golly, there's that one part number that I have to depend on the fab shop for if I want to order it from them, to use the description and not have an official part number. But yellow means it'll process. Red, on the other hand, if I try and run this stock list, I'm going to rerun that check. It says, you got to do something about this, or we're simply not going to run this stock list. I'm just concerned as to where are those lines and those mains, and why did it start numbering where it did. So I'm going to close this. I'm going to return to Revit. And it said one pipe didn't get listed. And other than that, the stock listing is complete. So it appears that it didn't list this pipe. And if I go back to the second floor, I'm going to try running the list again from here. Save the project. I think I'm going to try putting that start tag, start section marker over here, and see if I can get the stock list to start here. If I want to know where the numbers are, where is A1, where is A2, I can walker this. I'm sort of skipping ahead. Walker this and tag pipes. And I'm going to tag it with stock listing tags. And I'm going to put them at the middle of each one of the segments of pipe that they identify. And so A1 was this pipe down here, and W1 was this one branch line coming off the side. W2 was that long branch line going off the other side. Then W3, W4, W5, W6, and W6 had this threaded piping off of it in addition to those arm overs. If I clicked on those W's and I right clicked and I said select all instances in view, I could switch those so that they were horizontal, maybe not as ugly as those diagonal things. And I still have them all selected. I'm going to hit the up arrow and I'm going to hit the right arrow. And that's not perfectly cleaned up, but it's much more readable. And then I can one at a time go doctor them up a little bit more.
I'm sorry, Alan. So I went to the second floor plan. There's no tags. I reset the direction start point at that riser. I've got everything Walker. Did you have to go back to Hydra list and then auto stock list again
I am
to get the
going to.
tags?
Yeah, I am
Okay.
going to, but I didn't. I did a walker, and on the walker I said tag pipe, and tag pipe said,
Tag pipes. Gotcha.
and under
That's what
tag
it is.
pipe I've got center to center or cut or dynamic, but under that is the stock listing tags.
Okay.
And then when you pick stock listing tags, you say, do you want to tag at the beginning of each run or in the middle of each run or at the end of each run? And I picked middle.
Okay.
Now I'm about to run the stock list again, and I kind of expect the mains will be renumbered. A1 will be a different one. But when I get back, I think those are just the get back process updates that information, and the tags will reflect that new information. But right now, my A1 was at the south end of that cross main, and it listed A1, A2, A3 up to the north end, then came back and went 5, 6, 7, 8, 9, or whatever to get down to the riser manifold. Also, I moved up and to the right all of those branch line tags. The main tags are a different kind of tag. So I'm going to pick on one of those and select all instances in view. And then I'm just going to go to the left and I'm going to go up. Again, not perfect, but a much better starting point so that I can kind of see where that information wants to be at. And I'm just deleting those sort of working section lines that I put in before. This one, I'm just going to go move additionally. Okay. So I've moved or I've added another section direction marker, and I'm going to run my stock list from the second floor. So I'm going to WW the second floor, and then I'm going to Hydra list, auto stock list. I think everything is set up just the way that I want. So I'm just going to pick OK. It says you already have a second floor. I changed my mind. Well, yeah, I changed my mind. I'm going to make that 2ND FL. That'll make the name shorter enough that it'll probably all fit in one name. So go ahead and run that stock list. Main A still starts in that same place. And I don't know how far I want to chase that. Because everything's looking so good, I maybe just want to be happy with what I have. But there wasn't anything else new going on here other than if I did want to print this out, I'd have to deal with this, with these two things, and I'm just going to randomly pick some other thing. Just rod. Run the check. Okay, then I'm just going to take those two things and delete them. So I picked on the row that they were in, and then I picked this red delete arrows. And if I error check that section, that comes up clean now. So I should be able to process that. So I've got the second floor, and then I've got 2NDFL. That's the one that I like better than the other one. And this creates a PDF, and I could send that PDF to Ferguson, Coord, Maine, Wind Supply, and lots and lots of other fab shops. Whether they use Hydrotech or not, if you send this PDF, they'll know what you're looking for.
I blinked when you said process this and didn't see where you clicked.
Okay, so I'm back to the input screen, and this is the button that I used. Process.
Gotcha. Thank you.
And there are like 20 different reports out of the box. You're going to get at least one of each of the typical ones that you want. When it gets to Coord, Maine, they're going to have their own setup for the reports they want for their shop. You want to just make sure that when you process and you read that PDF matches your drawing. You're going to get what's on that PDF. Their job to make sure that they've got the reports that make their shop happy. You don't have to worry about that. But you do want to send, most typically in an email, the PDF and the HLF. And the HLF is 5 SMF lesson 5 end of day. Floor plans. No, I'm sorry. I'm reading off the Revit drawing. Here's the PDF in C, HES, training, 5 SMF, 2 FL, HLF. That file and the PDF that we got here when I said go ahead and process. Those are the two things that you want to send to the fabricator. But if you don't check it, it don't work. So read this over and say, yep, that makes sense. I know what we're doing there. And I'm going to kind of scroll down to the threaded pipe or the weld sketches. So this is the format that the shop typically looks at when they're looking at those weld sketches. I'm going to say, for me, the most interesting one is Main A4, which has 1 1/4 inch coming out the right side, 1 1/4 inch coming out the right side, and a 1 inch coming out the top. If I look at Revit, actually, I'm going to say I should close the stock list and in Revit tell it return to Revit. A4 is this piece of pipe, and there's 3'2" to a 1 1/4 inch out one side, and then I'm going to move this thing. There's 2'4" to a 1 inch out the top, and then 6'6" to a 1 1/4 inch out the right, and then 0'6" to no fitting. And I think I still have that PDF open. There's 3'2", 2'4", 6'0", and 0'6" to the 1 1/4 inch, the 1 inch, and the 1 1/4 inch. Okay, so we're going to keep moving. When you get back, you can add listing tags by saying select all the pipes, TP for tag pipe, and then click on center to center, not the beginning, not the end, but put it in the middle, the stock listing tags. And then I did a select all instances and then just nudge them up and nudge them to the left or the right. That gets them more readable. And then I did, if I said, I wonder where that main A4 is or something, there's another pipe schedule where you could find A4, click on it, and then say highlight and view, and it would take you to that main. And then finally, it's a good idea. We did this, read it over, say, does it make sense or not? And if it doesn't, think what you could do to make it make more sense and rerun it. Josh, this one's especially for you. Without some of the hydrotech background that some of the other students already have, if to get a better handle on what is this input screen about, how does the process work, there's a 30-page tutorial, mostly pictures, probably take you an hour and a half or something. But if you go to the help pull down in Hydra list, and you go to the document and open up the Hydra list manual PDF, and then scroll down to 386. I meant to put the actual page number in here. So you have to look for 386, and then that's where that tutorial is. I'm going to go back there with you or for you. So from the Hydra list ribbon, this is rerun the stock list. I've already run it, so I don't need to rerun it. I'm just going to launch Hydra list. That just launches that standalone program. And in here, if I go to the help and Hydra list PDF manuals, and I'm going to pick on not the label setup, but on the manual itself and open that. Then in here, this is where that says on 386. That's where that tutorial is. And 80, it seems like it's going to be somewhere around page 90 or so. So I'm going to go up here and just type in 90. All right, where did that get me to? 282. So I've got a ways to go. Let me try 190. That got me to 5, so it's halfway in between. Like I said, I should have put that page number on there for us. There's 3121, so we're in range. 392, 386. There it is, page 94. I'll put that on the slide for next time around. So here's a tutorial, and I think it's about 30 pages long. It's going to run a stock list by hand on that input screen for a system that looks kind of like the 60 by 80 foot building we did in the basic class. But in running that stock list, you'll get to see how to input the pipes and the fittings and the sprinkler heads and all of that. But it just walks you through pictures by pictures how that program works. You're unlikely to ever have to actually do that, but if you've done it once through this tutorial, you'll know how to tweak things that aren't quite right, and how to get them delivered to the fabricator and all of that. So there's like I said, those 30 pages are worth a look. There are other guys in class that have been doing that for the past 30 years, and they might not even have realized that tutorial was available. Good. Gerald, you're with us. You sent me a question. I got all excited and said, ooh, that's so easy. I'll show him how to do that. and then it fought me all the way. But your question was, could I show the safety margin as a percentage? Um, do you, what I'm showing on the screen here, do you think that'll do the way it is, or do they only want the percentage? They don't want to be bothered with the number at all.
Most of the clients that I deal with down here want to see both, but it
Cool.
is a big factor of wanting to see the percentage. I know
Good.
some parts of the country love the 10-pound safety factor, but there's other
Yeah.
parts of the country love the 10%.
Okay. So
But
by adding percent, parentheses percent, will probably make everybody happy.
that's
Isn't it?
perfect.
Super. So I thought this was great because we could take a family and edit the family and go move some stuff around, and then use that altered family from now on. When I went to do it, I said, okay, but I need to calculate a percentage. The percentage, and I'll tell you what I calculated. I said, here's the required pressure. The available pressure is this plus that. And the percent safety margin is this over that available, this plus that.
Right.
And Revit has built into it, you can report a value and you can report a calculated value. So I said, great, I can show Gerald not just how to solve this problem, but how that cool stuff works in the families. Then that's where the shit hit the fan. When I got in there, I found out this value exists in the family, but it's text. And this value is in there, but it's text. And Revit, unlike some more robust programming language, doesn't have convert this text to a number so that I can do math with it. That I'm hanging my head in shame that we did that. It's a number. It's a number. Why didn't we send it as a number? I think we were trying to get the formatting to work out better. So we said, let's do the formatting, and then the number won't move to the left or the right or the middle. It'll just be where we want to put it. At any rate, whatever the excuse, I created a family that has this in it, and in order for you to implement it, you just have to put that family in place in your project. I'm going to show you that. We're going to do that. Put that family in the project and fill out in numbers the answer to the system required pressure and the safety margin. And if you fill those in, then I'll have numbers and I can do the math and I can represent the percentage. So let me show you the mechanics of using what I did, and then we'll go look behind the scenes and I'll show you a little bit of how I did that. Sound good?
Sounds good.
So I'm going to close this view. I've still got my riser manifold showing up. While I'm on my riser manifold, I'm going to WW this, sorry, a detour for a second, go back to HydroList and say tag pipes, tag section IDs, put them in the center and OK. And so I had main 9, 10, 11, and 12 that we didn't have we couldn't see on the other plan view. You can add those tags to any view here. But then I'm going to go open the floor plan for the second floor, the one that I plotted, and that's the one that has that block on it. And the block right now doesn't have the required pressure, but we did do that calculation. And in the HydroCalc ribbon, there's a button that says update the demand info. I picked that button. This is information that we're going to homogenize across all of these demand infos. So on a really big project, you might have 2 or 3 or 20 of these things. We're going to make sure the project name is always small medical facility. We haven't finished that yet, but this is the first evidence of that work. I'm just going to close that and pick on this dialogue. And it went and found the hydraulic calculation and read the information out of the calculation and filled in those numbers. But again, he filled them in as text. If I click on that thing over here, yes, you see it has GPM written into it. And I think that might have been part of our excuse, was that INRAC says 0, but part of our excuse was that we could write bars, or we could write kilopascals, or we could write GPM. So that is what it is. Now, I'm going to take and replace this block with the one that I built for you last night. To do that, I sent this out file. Let me close all the other views so that I have two projects open. My new project with the new block in it, with the new family in it, and this existing one with the existing family. So I'm going to do File, Open. And this is the guy I sent out with the class files this morning. I'm going to open it. And for right now, I'm just going to say, trust me, there's some more information than this. This works different from the one that's in our real project. I'm just going to click on it, right click, and say Edit Family. And what I'm showing you here applies to this particular block, but to every block. If there's something I created in one project and I want it in another project, one of the easiest ways to ferry that family from one project to another is open the source of the block that you want, the family you want, pick Edit, and right away say Load into Project and Close. But you want to load it into not the project you came from, but the project you want to put it into. And on the way in, do you want to save it? I don't care about saving it. It's in my project, and I want to overwrite it. I'm going to overwrite it as much as possible, like get rid of the parameters or anything else to make sure they're all overwritten. Okay, nothing really obvious there, but this now has the new form of that family, and the new form has got these new properties, Gerald. Required pressure, which is 44.49, 44.49, and safety margin right here, 9.02, 9.02. And if you fill those two in, now I have enough numbers to calculate this pressure. What do you think?
I like it.
So if you don't fill those numbers in, it'll just give you the pressure. If you fill those numbers in, you'll get the percent as well as the number.
Al,
Yeah.
I think that would be a great thing to see, and I think that should be the standard. It should automatically have your pressure and the percentage. I think would be very helpful. And from a programming standpoint, that's why you use two separate fields, one for the value and the other for the units, side by side.
Good. And I actually intended to put that in the toolbox so that would be the standard, and it fits the scheme that I had way at the beginning. I said, start a new project, load the toolbox. That makes sure you get this latest one, and then go on. I was about to post that toolbox, and I got a note from support that said, Al, the toolbox you posted last week screwed up some people in Revit 2021. So they took it down. We'll get with the programming staff, figure out why that screwed someone up, and then it will become part of the toolbox. So, Gerald, I wanted you to see this morning. I didn't want to say we're working on it and you'll see it someday. That's
I
why I
appreciate
put the
that.
project.
Yeah.
But I could also say, and if you wanted to make that your standard, you could open the template and ferry that family into the template. I'm saying don't do that because it's only a matter of days before I work out what happened to the toolbox, and you'll just get it by starting a new project and importing the toolbox.
But what I'm saying is, I think that would be worth spending a little effort to fix the programming so that it actually filled itself in correctly. We use two separate fields, one to calculate the value
Yep.
and another to carry the units so that you can have both there without having to convert it to text. It still keeps it as a numerical value by keeping the units as a separate field placed side by side within the family.
Well, I think I'm probably going to go forward, Nathan, and make this be the new field, make this be the new um, family.
It's a great
And
internal fix. I just think it would be worth looking into at some point.
one, but I am going to get the programming but you'll get the benefit like by the end of the week just by getting the toolbox. And at that point, you will need to fill in those two numbers. If you don't fill in the two numbers, there's nothing bad happen. You fill in the two numbers, you get the percentage. By the next program update, I can get numbers automatically put in those two fields, and you'll always get the pressure and the percentage. And we'll preserve I don't want to show the percentage, just delete those two numbers and it won't show the percentage. Fair enough?
Fair enough. Thank you very much.
Thank
That was
you.
a great see.
Okay, I'm just going to show off a little bit here. If I right click and edit family, this family is pretty darn busy because originally the view we were looking at was the only answer, and somebody said, "Oh, I'd like a nameplate," and then somebody said, "Oh, I'd kind of like the whole summary sheet." So we made three different types of this family. Let me go back here a second. When you click on this thing, this is the family name, and the family has three versions: demand area, or nameplate, or complete summary. So same family, three different versions. And I make a point of that because that's a Revit thing. The hangers was a top beam clamp hanger, but that's the name of the family. The types were ring hanger or clevis hanger. So over and over, that's the way Revit handles things. You can have one family with variations in the type. Okay, so back here, this is showing all three of those gmushled right on top of each other. Down in the lower left-hand corner says preview the on or off. So I have three different formats, and there's a variable that says this one's visible for this type, this one's visible for that type, and that one's visible for that type. Under properties, I can go here and dial in the three different types. So I'm going to go back to just the demand area one. When I click that type, there's a variable down here that says demand area one show, the other ones don't show. Okay, and this thing says show only the ones that the properties mean to show. And then down here, I forget why I put this in a group. I think there's like all individual properties, and I want them to be all one thing that's on or off. So I grabbed them and I said, make a group out of them. I need to edit that group to be able to get down and see the individual values. And the value that says safety margin, I edited the label, and the label was reporting just safety margin, and I added a new property, and that new property was a calculated property, and the calculated property, I think I can edit the calculation, says, nope, I thought I could make that bigger enough to see. There you can see. So take the safety margin and divide it by the safety margin plus the required pressure. That gets you a number like 0.01 or 0.05. And then I formatted that. There was a place to format it, and I formatted it as a percentage instead of a number with a 1 decimal place. And then I got lucky, Gerald. If there were no values in there, it didn't blow up or it didn't give something ugly. It said there's no values in there. I'm just not showing it. So that made it fortunate that when we use it, if you type those numbers in, it says the percent. If you don't type the numbers in, it just shows a blank. And then I could load that into your project, and I didn't need to save it. Overwrite. Okay. Anyone additional thoughts, comments, or questions on that? Cool. Then I'm gonna move ahead to 3 other topics. One topic I have scribbled down here, and I want to make a point of. So there's like 3 or 4 more things that I want to cover, and I'll bet you I'm going to run out of time. I'll wait and see who runs out of interest. I'll just plow on through as best we can here. However, not on this list, but on my handwritten list, a question came up about dimensions, and dimensions are really cool in Revit, but I want to explain some of them. I want to put a dimension from the inside of the wall to this branch line, to the inside of this wall, to the other inside of this wall, to this arm over, and like that. Almost always use the aligned dimension tool. If I hover over the walls, right now up here it says look for wall faces. If it were on wall center lines, then by default it would highlight the center line. If you hit tab on the wall, it goes to the other features of the wall. So even though it says center lines, I can get the inside of that wall. Then I'm going for that pipe. Then I'm going for switching this back to faces. And then I'm going to that face and that face. And then I'm going to accidentally miss that sprinkler and go on to that pipe. And I can go on and on and on and on. Sooner or later, I want it to actually do it. Your AutoCAD sense says pick enter. That does not work. Do not pick enter. The requirement is pick on nothing. Josh, do you see that's not nothing? I don't know what it is, but you see the dark blue line showing up? I don't want to pick there. If I do, I get an extra dimension tag. If I pick there again, it undoes that. That's the cool thing. So I meant to park my dimension up here, and I picked on that thing by accident. I got an extra dimension line. Just pick on it again, and it goes away. To finish the dimension, you pick on nothing, and that finishes the dimension. If I click on any one of the pieces of that dimension, I can move the text. So these 5-inch walls, I could pull out. Oh, this 12 feet was the room dimension, but I missed this sprinkler. If I pick edit witness line, and then I pick on the sprinkler pipe, it just adds that. It adds that dimension line. It's that simple. Then I'm going to hit escape, escape, escape. Or do I want to pick on nothing? I change my mind. Click on the dimension line, edit. It's always pick on nothing to finish. So do that, and then nothing, and it finishes it. Anything else I want to say about that? If I wanted to do the heads in the other direction, I would do from the inside of this wall. And if I'm really careful, I can get that sprinkler, but I got to zoom way in to get to the sprinkler. And then the inside of this wall, the other inside of that wall. And then I got to zoom way in to be really careful. To make that easier, if you pick on the sprinkler symbol, the sprinkler head, there's a property under edit type. So there's all these properties for every sprinkler of that type. And at the bottom is the thing that says show alignment guide. And now every sprinkler has a 2 foot by 2 foot box that it's centered in, and it has a crosshairs through it. So now if I want to dimension from the inside of this wall to that sprinkler, it's really easy because I've got those crosshairs to work off of. Inside of the wall, inside of the wall, crosshairs inside of the wall, and now I've got to pick on nothing. So there's a place with nothing. And there's that, I'm looking for the 5 inches in there. And if you go just far enough, you'll get that leader.
Can you cut those 5 inches ones out, or will it? Looks like it only deletes the whole thing.
No, I think I could. It takes a little bit of doing, but I could say replace with space.
Yeah.
So it says 0 foot 5, replace with, I'm going to put dash in there. And obviously it's kind of silly to put the kind of silly to have an arrow to say nothing.
Yeah.
But that's the first one that occurs to me. You can put a prefix and a suffix or a replacement for the text. Just a reminder, the one really big difference between AutoCAD and Revit as far as dimensioning is concerned is AutoCAD is basically dimensioning from a point in space to a point in space to a point in space. You can pick on something or on nothing, and it'll put a dimension. In Revit, you're dimensioning between objects. You must pick on an object. Once you've picked on the object, and the align dimension is the best one for that, but you're trying to pick parallel lines to align to. Once you've picked on the object, if I wanted this to be 5'3" instead of 5'2½", the trick is to pick on the object that you're going to move. And you see, I got gypped. I thought I was dimensioning to that. Well, let me go the other one. The other one I know that I used this. Do you see how the dimension changes? This one, it's not the sprinkler head that I actually dimensioned to. It was the pipe that I dimensioned to. So I'm going to go turn those guidelines off. And that's a type property, so I'm turning it off for everything, every one of the sprinklers of that type. And now if I pick on the pipe, that's what I dimensioned, and then I can change this to 5'3" if I want. But that's critically important. You're sucked into thinking, oh, I could pick on the 5'3" and change it. No, Revit's confused if you do that. Should I move the wall or should I move the pipe? He doesn't know. If you pick on the pipe, then he'll let you change that dimension. He'll move the pipe and he'll change the dimension.
Can you show how to get the 5 inches again?
You want to get rid of the 5 inches. So
I want to see how you got it in there after you dimensioned everything.
Okay, when I clicked on the wall, it added the 5-inch dimension. I was dimensioning to the wall, to pipe. And that's where the 5-inch dimension came from.
Well, I know where it came from. And just you were originally doing center to center walls, were you not?
I switched to center and I switched back to face. As I'm dimensioning, edit witness line, I guess it was the dimensioning itself. In here it says dimension to center lines or faces. But if it's on center line, then by default it's looking for the center of the wall. But if you hit the tab key, it'll go to the other features of the wall. See, I'm getting the face, I'm getting the center, I'm getting the core, and then I'm getting the face.
I guess what I mean is, like, if you've already got your dimensions out, you go, oh shoot, I forgot to put my wall dimensions in there.
Okay.
What do I need to do?
Okay, so just you click on the dimension and you hit edit witness line. And then in this case, I don't want the wall, so I'm picking on it. That's getting rid of it. In this case, I forgot the wall. So pick on the wall. I'm going to go to there and then pick on the other wall. So it's a string of dimensions. That string behaves as one thing. But when you say edit, I'm clicking on nothing. When you say edit witness line, if you want to get rid of one, just click on the one that you want to get rid of. If you want to add one, just click on the thing that you were missing.
Okay, I got it. Thank you.
Not super intuitive, but after you realize that's the way it works, I think it's pretty damn cool. Okay, so that's what I wanted to brag about dimensions before I got onto the next subject. Now I want to brag about doing stairs. I'm going to use the spacing and layout tool and treat the lower level of the stair as its own little room. So I'm going to put an upright sprinkler in here. I'm going to do the upper level and treat that as its own little room and put a head in there. And then I'm going to stay at 5'10" and get started into the hall. I'm going to stay at 11'10" and start into the other part of the stair. And then I'm going to draw a flat pipe either at 5'10" or 11'10", anywhere as the down the slope pipe. Then I'll switch to the section view and align that flat pipe to the slope. And then in the section view, I'm going to trim and extend the equivalent of AutoCAD fillet. I'm going to fillet the slopey pipe to the flat pipe, and it'll put a swing joint and clean up the corners. And I'll do that at both ends. So I'm going to treat the landings as small rooms. I used a section to get a good place. I'm going to say 5'10" will get me under the standing the stair landing, and 11'10" will get me under the beam for the upper landing, and deal with those two as small rooms. So let me go do that, and then I'll come back and do the rest of these pipes. So over here, I'm going to go to the ground floor. And I'm going to treat this as a small room. So I'm going to spacing and layout, upright heads. Use that upright head. I'm going to include pipes. I'm going to make the pipes, any of these is fine. It's like only 20 square feet or something. So if I said 100 square feet, 130, 220, they're all going to work. But I want the piping to go left and right. I want the piping to be lines threaded. And I'll use 1-inch pipe at not below top of steel. I want to come up from the floor 5'10". And then I'm going to not pick a room because the architect doesn't treat that as a room. I want to. So I'm going to pick 2 points and click there and there, the upper right and the lower left corner. And that's going to put a head right in the middle of that space. I'm just peeking out at the green thing, or I could hit escape and insert pipes. Now I'm still at 510, and I know I want to be at 1110, but for this upper stairwell, I'm going to go from that corner to that corner and pick the red button and say, I changed my mind. I don't want 510. I want 1110. Other than that, it looks okay. I'm going to pick the green button this time. And so escape, escape, escape. I have this pipe at 1110, and I have this pipe at 510. I'm going to drag this pipe back, right click on the end and say draw pipe, or create similar will do. That gets me into the slopey part of the stair. I'm going to take this pipe and drag it back till it lines up with that one, and then right click and say create similar and get started in there, escape, and I'm going to draw another pipe parallel. So this one's flat at 510, this one's flat at 1110, and this one's flat at 1110. I have a section line that's going through there. We used that on our sheet the other day. And here's my flat pipe, here's my flat pipe, and here's my flat pipe that should be a slopey pipe. I'm going to click on it and say, this is a Revit command, align to this, that. So I'm going to align to this slope, that pipe. And then I'm going to click on that pipe and move it just down a little bit so it's underneath that slopey landing there, the slope holding the treads. And now I'm going to use, click on a pipe, get the modify ribbon, and use this button that looks like fillet. It's called trim and extend. And I'm going to trim this slopey pipe to this flat pipe. And it's like a fillet, but they're at two different depths in the section. So it puts the swing joint in between. This one I have to be a little bit more careful. I want to trim this pipe to this pipe. But you see that dotted blue line? If I click to the left of the dotted blue line, I'm going to keep an acute angle and I'm going to keep the pipe on the left. If I pick on the right side of it, then I'll get an obtuse angle and I'll keep the pipe on the right. And that's just exactly what I wanted. If I walker that and do a 3D view, there, I'm claiming that's a thing of beauty. I can use delete pipe to turn that into an elbow, and on the other end I can drag that onto our main, and then we'll be running under the two landings, sloping in between them. So I'm going to go back to the ground floor. I'm going to DP, pick on that pipe, and it changes the T into an elbow. And then I'm going to take this pipe. Oops, I didn't want to DP that one. Control Z, escape, 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 Control Z. I wanted to take that one and drag it onto this main. Okay, so that's stairs. You could use the roughly the same scheme, but treat the riser as a room and tell it that that pipe is on a slope. You'll need to measure the slope ahead of time so you can tell it, like we did for the lobby, that the slope is 8 inches in 10 inches or something. And that'll put a sprinkler under there. Similarly, you put a sprinkler under there, and then you do the flat pipe, and create a swing joint. Good deal. I want to talk quickly about dry systems, and then I think I'm going to maybe try and include in my PDF that I send out, the slides for the rest of this. If anybody wants me to do the other two topics, the pump room or the standpipe, I'll either hang around or point you to a thing that points you to a video that talks about those. But let me go do a really quick layout of a dry system feeding that spec area of our small medical facility. So I'm going to space the sprinklers below top of structure. I'm going to put the sprinklers at 1'2" down from the structure. The sprinkler is the base of the sprinkler, so the deflector will be within 12 inches, but kind of as low as I can get it. Then I'm going to route the mains and the lines on the slope. Then I'm going to connect the lines and mains to get them to go all connected to each other, but still be sloping. And then I'll connect the heads into the lines and mains. So over here in the ground floor, lower level plan, I'm going to take this elbow and delete it. And then I'm going to walker what's left. That's my ground floor stuff. I'm going to delete that. And then I'm going to lay out sprinklers sort of for the spec here. So I'm going to sprinkler spacing. I want uprights. I'm not going to draw the pipes, just the sprinklers. I use upright sprinklers. I'm going to expand the head data and put them at 130 now. Then there'll be plenty of places for us to hook up pendants when they put rooms in. And I'm going to put them at below top of steel, 1'2". So I don't need to know just how high the ground is. I'm going to go measure down from the below the top of the structure. And then I'm going to pick 2 points, or in this case, I can actually pick a room. And if I hover over here, it should go to pick a room, and it's not doing that. Escape, escape, escape. Let me put a room tag on that just to prove to myself that we can do that. Annotate, room tag. He's being shy. Why is that? You know what? I'm seeing the structure here, and I have our view range way up, and the rooms are probably down a little bit lower than that. So I'm going to go to the view template, the view range, and adjust that. Where'd you go? View range. I'm going to put that back down at 4 feet. Okay, now it might be easier for him to find rooms. I'm still on annotate. I'm going to pick room tag. Sure enough, he's let me type that. Kind of a clue for me is it found the stairwell, but it didn't find this one. So that made me think the view range was too high. So now if I go back to spacing and layout, this should all be fine. I'm going to do pick room, and I'm going to space sprinklers in that room. Interesting that I got 5 branch lines. I'm going to escape and revise the setup and ask myself, I could put the heads as far as 15 feet apart. What if why did I need 5 branch lines? I probably shouldn't object to that and just keep going. But the last time I did it, it only needed 3. So I'm just wondering about that. I can go as much as 15 feet. Let me make this 150 and see if that makes any fewer. Now I've got 4 branch lines. And I'll take that head and move it out of the wall. It's moving only 3 inches at a time, so I got to click on them a bunch. And now I think I could live with that. So I'm going to, my green is off the screen. I'm going to hit escape and insert sprinklers. Okay, so I've got sprinklers all around there. The room excluded this thing. That thing was a different room, but I think I'm going to take these two sprinklers. And he's warning me that it's an open sprinkler. Oh my. And I'll copy it up there like that. This is spec, so I'm just going to use that. Did I get a sprinkler? Yeah, this one likely can get over to that wall. So now I'm going to run the pipes at a slope. I'll start where I was at before, or no, I want to look at that sprinkler and put my piping at the level of that sprinkler. So this thing's at 12'2". I'm going to run a pipe from 12'2" going down, or I'll start over here at 12'2" and I'll come up. 12'2" is kind of the lowest I want to be, so I'm going to go up from there. So I'm going to start over here at 12'2" and go up a quarter of an inch and 10 feet. PI is for pipe. I'm going to use 3-inch, and my elevation is going to be 12'2". And my type is going to be mains welded. And I'm going to slope up over here. I'm sloping up a half an inch in 120 inches, half an inch in 10 feet. I'm sorry, this is mains, only a quarter of an inch in 10 feet. So I'll start in the vicinity of this. I'm going to go shallow for now and get this thing all lined up first. And then I'm going to come down here. And now I'm going to change to 1.25 inches. This is not really important. I'm going to make it 12'2", and because it's going to adjust, I'm going to tell it to connect into the main wherever it's at, and I'm going to make it lines welded. And then I'm going to start here and put one up to there. Escape. I'm going to start here and put one up to here. And I'm going to escape and start. That's embarrassing. I think I'll start here and come up to there. And then I'm going to start here and come over and up through these guys. So those pipes, all of those pipes that I just drew are sloping up a quarter of an inch in 10 feet. And due to the time, I'm going to accept that it's supposed to be a half an inch in 10 feet. I should just plain redraw those pipes. But I'm not. I realize I made a mistake, and I'm just telling you I'm going with it. I don't know. Could I change this? Okay, now that one's going up a half an inch in 10 feet. And that one is going up a half an inch in 10 feet. And this one is going up a half an inch in 10 feet. If I had discovered this later, like after I'd connected it all and all of that, I'm saying probably the best thing to do. So he's not letting me change that one. Will he let me change this one? Yes. Would be disconnect the heads and probably even disconnect the lines from the mains, and then go change those elevations and then reconnect the heads. It's a serious temptation. It's a serious temptation to try and keep them all connected, and that's where things go sideways. Easier to disconnect them, reslope them, than reconnect them sloped. So I'm following these instructions. Route the mains and lines on the slope. I think I'm going to switch these two. I'm going to connect the pipes and join them to the mains, and then I'm going to connect the heads into the branch lines. So over here, I'm going to see if I get away with this. TR, trim and extend that one to that one. All right. This pipe is still 1/4 of an inch, just a tiny bit less than 1/4 of an inch because it connected over here. I'm going to think that's still okay. Would he let me get away with making that 1/4 of an inch? Look at that. So as long as they're disconnected, it's easy enough to re-slope them. But this pipe is 2'3" and something at this end, and this pipe is 2'2" at this end. But if I use my connect pipes tool and I say, raise the pipe up to, so connect into this and raise this pipe in before you connect it. Now you see this one's at 12, almost 3, and this one's at 12, almost 3. Those things connect to each other, but this pipe is still on a slope of 1/2 inch and 10 feet like I wanted. And now I'm going to do the same thing with these other 2 branch lines, and I'll do them both at the same time. So connect pipes, raise it in before you connect it. So raise it to this, that pipe, and finish. And then raise this pipe. I'm going to start over, connect pipes, raise into this pipe, this one, and finish. And now that's, guy's still 1/4 from before, but this guy's still 1/2. And now I can connect the heads. So back to spacing and layout, configure head. Arm overs, anything within 2 feet is going to get connected. Connect heads, connect these heads to that pipe, these heads to that pipe, these 2 heads to this pipe, these 3 heads to this pipe, and these 3 heads to this pipe. And you might notice that the sprinkler symbol disappeared. That same thing happened to us in the lobby. If the head is at an angle, then that symbol says, oh, this isn't parallel to the floor, I'm not showing it. And then we faked him out by just letting you pick all the heads and go into HydroCAD pretty sprinklers, and we'll do better than make it show. We'll make it show, and we'll make the pipes not go through it. And then I'm going to take that pipe, control that pipe, control that pipe, and control that pipe, and say add 6 inches or make it 6 inches and put a cap, and then I'll go 6 inches and a cap on that guy. And these little darts are concerning, but if you look closely, that's the copper tube that's not connected. That's the plumber's problem, not mine. So I'm not going to be upset about it. And then I could, I'm just going to check that and notice that that's fire protection wet. If I go back to our systems thing, I'm going to double check what's going on with that. That was view, the system browser. And we still have 4 systems, but I kind of rebuilt that. I rebuilt that one. Well, no, that says lower level. There we go. So I built that off of this one pipe that was system lower level. And when I tied all those other pipes into it, that became the lower level system also. So I'm happy about that. And I think I'm going to kind of quit there. I did a lot of work on this slide. I can talk my way through it in a minute, and I can come back to anything you'll want to hear about. But whenever you use add device, it's part of that deck the halls thing. Route your piping to go where you want. Fa la 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 la. Add device to decorate with valves as necessary. Escape, escape, escape to start again. Use the CP, add the couplings. Escape, escape, escape to start again. Use DP to clean it all up. Escape, escape, escape to start again. So always leave lots of room when you route the piping. Then add the devices and still leave lots of room. Then put couplings necessary to put them together. Still leave lots of room. Then use delete pipe. And delete pipe can be a pipe, a pipe, a pipe, or it can be a fitting, a valve, a valve, a fitting, a valve, and then smush it all together so that they come together. Now, when you do the pump itself, you use exactly that scheme. You route the piping, you add the devices, the backflow and all that necessary for the suction system. Then you insert the pump. There's a button specific to doing that. That's called insert pump. And there's horizontal, vertical turbine, and end suction. I'd say the most popular is the vertical, the horizontal split case. The next most popular is this vertical inline, and you use this almost always with a really small size, or any of these that just specify the phase. Is a really small size, 1.25" suction and discharge. That's a jockey pump. But a regular fire pump, you could use a bigger one of those verticals, or when you're reading this list of available pumps, the 4 is the discharge pipe. So I picked the first one that the model number included a 4, and that pipe has a 4-inch discharge and a 5-inch suction. I'm going to do a video and post it. I haven't actually done this one. Whatever is there is relatively old. When you put the pump in, I would recommend being on the ground floor when you do it. When you put the pump in, don't try and hook it up to anything. Just get it smushed into the middle of the floor. So HydroCAD, insert pump, horizontal split case. I'm going to pick that first one with a 4. If I wanted to cheat, I could make this be a 4-inch suction, and that would make it easier, but I'm going to go ahead and leave the 5-inch and then stick it in your floor. If you click on it, one side is in and one side is out. I'm going to rotate it so that I could hook that up to a suction pipe like I had, and then I could drag that onto my suction pipe. The video, I'd say wait for it and watch for maybe an update to the toolbox, or at least a message about more videos. Helpful video fire pump, that's where I'll put it. I'm going to get fancy on how you put a flange set and how you put a eccentric reducer so it's flat on the top, and wire those things together. But the trick is do all the suction pipe, do the pump separate, rotate it so that it lines up, and then drag it onto, or use to this, connect that to get the pump onto the suction pipe. Then you can repeat for, I'm going to go back here, repeat for the discharge side, for a bypass, for a test header, for a fire department connection. But it's the same thing over and over and over. Route the pipe, add the devices, add the couplings, clean it up with DP. And one special thing is when you're doing calculations with a fire pump, you want to make sure that the walker system will only go through the fire pump, not the jockey pump, not the bypass loop, not sneak through from one system to another through the drain piping. So any extraneous loops should get excluded from the calc. by picking the start pipe and the end pipe of each of those extraneous loops and identifying those as system dividers. Then when you run the walker, the, the, the walker will go through the fire pump and it won't go through the other stuff. If it does go through the other stuff, the calc will get confused. The standpipe has just a couple of things special about it. If you're in a high-rise building, you probably have multiple levels already defined. If you go to the lowest level, oops, I keep trying to zoom in on a slide, and that doesn't work. I'm going the wrong way. All right. Zoom in on probably the lowest level and draw a threaded pipe coming off of the branch line. Then you go to add device and get the angle valve, and you can drag it onto that pipe. Then if you've got floor control assemblies, you could repeat that process for drawing the floor control off of it and copying that. But then each valve, when you go to calculate it, wants to know whether it's part of the standpipe calc or not. And there are four variables that need to be filled in for that. For sprinklers, it's flowing and remote area, and then it's density, pressure, and coverage area. And for hose valves, it's flowing and remote area, and then the flow, 250, and the pressure typically is specified by NFPA 20 to be I'm sorry, by 14, by NFPA 14, it's specified to be 100 PSI at that hose valve, but it's at the outlet of the hose valve. And recently, the manufacturers of the hose valves have been testing them and publishing the friction loss in the valve, which is often around 3 pounds. So I said, start at 103 here. That'll give you the 100 that you need there, but do it based on the listing of the hose valve. If you don't have the listing and you don't have that friction loss, NFPA 14 specifies 35 equivalent feet, which gives you about 6.5 pounds. So I'd recommend you get that 3 pounds back by finding a listed hose valve that reports that friction loss. So set those, and then you can pick a window here and copy, and then you can say paste to the other floors. You don't have to paste them one at a time or copy them one at a time. You can say copy this to floors 3 through 19, and it'll put them in all of those. And then that connect pipes that we used in the dry system, you can use here and connect them to the rest of the standpipe. And that's kind of the bum's rush on the last few topics, but I did have it in the PowerPoint that I'll send out later. You can take a little bit more time with it then, and by all means, nudge me if you say, yeah, I'd like to see that. I'll work harder to get that in a video and tell you where that is. Other questions, other thoughts that came up, either over the course or what we went over just now in today's lesson.
About 1 million, Alan, but I do need to step off, so I appreciate the time and wish everybody well.
Thanks, Jason. It was great having you in class.
Yep. Take care, everyone.
You bet.
Alan, I would like to say thank you so much for all of your effort and trying to help get us up to speed. Much appreciated.
My pleasure, and I kind of especially like hearing from you in the next few weeks. It lets me know that you're exercising these things, and I can't possibly cover everything that you're going to need. So give me that chance to fill in the couple things that are missing. Well, thanks, everybody.
Likewise, Al. We appreciate it.
Thank you. Thanks for being a part of this. We'll we'll hope to catch up with you guys as we go along. And I wish you all the success in the world with these exciting tools. Thanks, everyone.
Thank you.
Thanks, Al.